I'm Anna Hoffman.
Hey friends, I'm Nikolai.
Hi, I'm Mustafa Turaman.
Hi, I'm Tanya Janka.
Hello.
And I'm excited to be the speaker at Azure Summit 2021.
It's a fantastic event that will be 11 days live streaming,
Where more than 100 speakers from all over the world.
I'm excited to speak at Azure Summit about Power BI and Synapse Analytics.
And I'm going to talk about security.
And also a Microsoft MVP for Azure.
I'm speaking at Cloud Summit about automated release of .NET application.
And the best part is that this is a free event.
Come join me live at Learn TV on September 17th.
Come join me live on Learn TV on September 14th.
Come join me on Learn TV on the 14th of September this year.
A bunch of other Microsoft and community speakers.
So if you want to learn how to secure Azure, come to my talk.
join us. It will be a lot of fun.
See you there.
See you there.
See you there.
See you there.
Hi everyone and welcome back to Cloud Summit 2021. This is day 5 part 1 and what an amazing first 4 days we have had at this summit. And I cannot believe we are on day 5, but can you also believe that we have to go till day number 11? And yes, it's the 11 days of Cloud Summit featuring more than 150 speakers, 120 sessions, streaming 11 days and approximately 10 to 12 hours each day in all time zones. And it doesn't matter if you're a newbie or you are an expert. This summit covers the entire ecosystem of Azure. So I'm really excited for day 5 of Cloud Summit as we have a really exciting sessions to go ahead and get started. Today we're going to talk about Azure SQL. We're going to talk about ARM templates, Bicep. We're going to talk about security. We're going to talk about Azure Synapse. So there's a lot that's covered in today's agenda. Having said that, first thing first, I've been looking into the comments from past 4 days. You all have been very nice, and I want you all to continue with to be nice to each other and follow code of conduct. And as I always say, there's 3 contests always running. The first one is a live comment contest. So whenever you drop a comment in the chats or ask a question to speaker or share your thoughts, please use #CloudSummit. And we will go ahead and pick winners towards the end or after every half. And please go ahead and take a selfie, do a screen grab, tag us on social media with Cloud Summit Live using #CloudSummit, and we'll make sure that towards the end of the day, we pick one winner from each social media. I see many people are joining now. I saw people are joining us from UK. Mirza says, here's a quick question. Mirza says, I've missed the first 4 days. Do I get recorded session? Yes, you will get recorded session, Mirza. Don't worry about it. Just go ahead and register, and after the summit ends, we're going to drop you an email with all the recording links with the individual sessions. So you not only get the entire day, but we'll also record it and sort it in different topics. Welcome everyone. Welcome Santosh. I see some people who are joining us very regularly. Santosh, Ganesh, Mirza, Andrew, Himanshu, welcome everyone. Iqbal has been very consistent, so welcome Iqbal. Having said that, let's, without any further ado, let's invite our very first speaker of the day. And today we have Taiob Ali. Taiob Ali is going to talk about Azure SQL database. Where is my SQL agent? I did have opportunity to host Taiob Ali in the first quarter of this year, and I'm really excited to host him once again. So without any further ado, let's invite and start day 5 of Cloud Summit 2021 with our speaker, Taiob Ali. Welcome, Tayo. Welcome to Cloud Summit 2021.
Good morning, Simon. Good afternoon. Thank you. Thank you for having me back.
Yeah, I'm really excited. I know it's very early morning at your place. You're joining us from Boston, right? If I read that video.
Correct.
Right, and it's 6:30 in the morning. So I'm really excited for your session, Tayo, right? And I already have I see you shared your screen. We're going to do chit chat towards the end of the day. And everyone who's watching, please feel free to go ahead and ask a question to Tayo. He's going to talk about Azure SQL Database. And those who are asking that, what is the schedule for today? If you're on if you're watching us on website, you can just scroll down and you can see the entire agenda. And if you're watching us on YouTube, you can check the description. Having said that, Tayo, I have added your screen to the stream. Everybody can see it. And next 40 minutes is all yours.
Okay, thank you. Welcome, everyone. Thanks for joining. Before I start, I really want to thank Simon and his whole team. You know, this is extraordinary work by the whole team to bring this around the world for so many days, so many speakers, and on top of that, it's free of cost. If you go to some of these big conferences, they can cost you some big bucks. So I appreciate that. Plus, I appreciate the opportunity to come here and speak to you. I don't take this very lightly. So let's move on. What are you going to talk about today, right? So we'll be talking about Azure SQL Database. Where is my SQL agent? You probably already saw the topic. Hopefully you read the abstract. So I'm just going to move on. And I'm not going to read this slide because, in the interest of time, and you can read this by yourself if you want to, but take a note of my contacts on the left. This is more important because we have very limited time. After this presentation, I'll share my materials with Simon, or you can go to my GitHub page and download everything. And if you have any further questions, follow-up comments, please do reach out to me using any of these methods. I do monitor all of this, and I can guarantee you that I'll be getting back to you in a day or two. So why we will be talking about this? And this talk is, Azure SQL Database definition is broad enough, right? So, it can include SQL Server running on Azure VM, managed instance, hyperscaler, and all that. But this talk is exclusively for PaaS service, means Azure SQL Database. Now, if you've been using Azure SQL Database in any form or shape, the first time when I started using it, my shock was, where's the agent, right? I need my agent, right? And I couldn't find it. So what's going on there? So, and why do I need agent, right? Why I was looking for it. So even though you are using Azure SQL Database, I just highlighted some of the stuff in this slide, and this is not a, not a full-fledged list. We still have to take care of some of this stuff, right? I'm not going to read this, but then how do we do this? So that's kind of the guts of this talk, that even though you move to cloud, you still have a couple of things that you need to take care, and this is that's why I started looking at it, and I found my solution, and I wanted to share it with all of you. Now, the things that I'm going to share with you, it doesn't have to be just one thing for everyone, right? Because one size does not fit everybody. So let's move to the next slide. So what I'm talking about here, I'm saying, most of the people that I talk about, including myself, I'm in a hybrid situation today. And what does that mean? I have some resources on premises. I have some resources in the cloud. So I can leverage some of the stuff or some of the resources that I have on premises to do maintenance against my Azure SQL Database. So that's the option. Also, some of the solutions that I'm going to show you, what you can do is, and what some people have done when I talk to them is, they stand up a VM in cloud. Say, you do not have anything. You want to shut down your data center completely. You want to go to cloud 100%. you can have an IaaS VM there, and then over there you can use the PowerShell module. You can use your Windows scheduler, or even you can install a SQL Server, same as on premises, and use that to control your stuff. Now, some of you might say, no, I'm 100% cloud. I don't like IaaS. I want to go full PaaS service. Yes, for those people, look at the third column. There's Azure Automation, Azure Function, Elastic Job Agents, and Web Jobs. I'm not going to talk about Web Jobs, but I'll talk about the first three. So you have the capability to go 100% to cloud. Now remember, Azure SQL Database is a service. Azure Automation itself a service. Azure Function or Function App itself a service. So they are all independent services, but you can glue them together to do the stuff that you need. So the first one, I said I can still leverage my on-premises resources. What does that mean? So if I have a SQL Server, I can create a link server to Azure SQL Database. And if you do not know what's a link server, look it up. We do it. You can even use a link server on premises today. You can connect to a different server and pull and push data from there. So you can do that to Azure SQL Database too. If you know PowerShell, if you don't know, I will highly recommend start looking at it. Microsoft is heavy on PowerShell, and it's just going to increase, over the years. So start looking at it. So if you know PowerShell, you can run T-SQL using some of the PowerShell commands. And then Windows has a built-in scheduler. So in SQL Server Agent, the way we schedule jobs, you can do the same with built-in Windows scheduler. So you can have your PowerShell code run using Windows scheduler. And I'll demo most of this stuff, depending on the time that we have. And what you're looking at here is it's just a copy paste from Microsoft's documentation, Azure Automation. So with Azure Automation, what you can do, there's something called runbooks. I can have a runbook, and I can trigger the runbook through many different ways, right? I can do it from Azure Portal. I can do it through Webhook. I can call that from PowerShell. I can even have Azure Alert go and call a runbook. So to give you an example, when you set up a Azure SQL database, you do mention what's your max size. So if you're monitoring your size at X minute interval, and you suddenly see that you reached a threshold that you want to increase your size, right? So if you have hundreds and thousands of this Azure SQL database, you cannot do this manually. So that Azure Alert go and trigger a runbook, and then scale up or increase the size of your Azure SQL database. You can scale up a VM, scale down a VM if you need to, based on your on demand. So I added this here because this is a nice short video. As you can see, it's about 13 minutes to give you just a how to get started with Azure Automation if you're not familiar with. And there's a tip on side tip. So Azure Friday is a good thing to follow. You can have RSS feed. They come out with these short videos. I know all of us busy. We're trying to do hundreds of things, especially with COVID, staying home, taking care of children. We don't have much time. So this is a very compressed, kind of a good dose, in a short period of time on new topics. So the next one is the Azure Function. And Azure Function, initially when it was deployed or was released, was not really perfectly suitable for the maintenance kind of jobs, but they really improved, in last few years. Now it supports multiple languages, as you can see in the bottom on the left side, PowerShell, Java, .NET, Node.js, and whatnot. So, and there were few limitations before. You can also use Python. So, there's some limitations on the max runtime and all that, but a lot of those things has been extended. So you can, you depending on what language you are using, you always have have more options. And in VS Code, there is extension actually for Azure Functions, very nice. So you can, staying within VS Code, you can edit, deploy, or test your functions against your Azure SQL databases. These are two quick links for you to get started. Yeah, Shanta says Azure Friday with Cloudstone. So Azure, Friday. I mean, 2 days of Friday nice. Azure Friday is also nice. The last one is Elastic Job Agent. So if you want to, if you ask me like what's like most similar to what we are used to today with the SQL Server agent job, that's Elastic Agent job, right? So as you can see in this picture, there's a job agent, and I need a database to hold the metadata of my jobs, schedules, and all that. And I need another database, or you can do it in the same database to write your output, right? Was my job successful? How long it ran? And all kind of stuff. Now, what can I do with Elastic Agent job? I can do Elastic database jobs. I can run it against a single database, all the databases again in a server, or I can have multiple servers in a pool, or as a target, and I can run my job against those. There are mainly 4 components to this, as you see on the right. One is Elastic Job Agent, Job Database, Target Group, and my jobs. So in order to turn on this Elastic Job Agent, you have to specify a Azure SQL database. Now, do you want to mix it up with your user databases? Probably no. So you might want to have a have a dedicated Azure SQL database for this. And the minimum recommendation is a S1 tier. But remember, if you have thousands of jobs are running, you probably want to use a bigger one for compute purpose, right? So be careful over there. And there are some security you have to set up, right? Because you are running it from one place, and it's going to go to all the target target Azure SQL databases. So make sure your whatever way you set this up. And there are different ways, but I will show you. I also have a set of code that you can use to get it started. But make sure that security context is set up before, right? Because that account that you are going with when you're running your job must have privilege into those databases. If you're only reading data and doing your baseline, yes, you need read permission. But if you want to modify it, or to do your some index maintenance, statistics maintenance, and all that, it will need a little bit more permission. So you have to figure those out before. Someone asked, will the links in the presentation be published somewhere? I do not know. I think I can put in the chat if I have facility. I can, and I'll show you my my GitHub page that you can download everything. I'm going to upload it there or refresh it. Actually, I made some modifications. These are a couple of examples that what your target can be. So I'm not going to read this slide because this is from Microsoft documentation. So you can see, you can set this up many different ways. And as you see, for each example, there is a small description, like individual database, all database in server. You can exclude one. You can, do it against all the Elastic pools and whatnot. So now once you turn on your job agent, doesn't matter what database, because remember in Azure SQL database, there is no MSDB. So if you go to Azure SQL Server, it's just a shell. You only see a master database and you don't see all the stuff that you see on an on-premises master database. There is no model or MSDB. And there is a TempDB, but you can't even see it. So as soon as you turn it on, you see all these system objects get created. And if you look at some of these, right, we already know some of this, SP-job, SP-job. Today, we have all this in the MSDB database. So it's probably the same code base that they're using it. One drawback I will mention that the reason I do not use it in my workplace is it still doesn't allow PowerShell code. So many of my jobs run centrally from a central server that I use PowerShell and go and loop through whatever hundreds and thousands of server and database. I can do this here, but it just doesn't allow PowerShell. So that's one of the drawbacks till today. The max is 100 concurrent jobs. It keeps the history by default for 45 days, and then get purged. Depending on the resource that you assign or the database that's being used as your agent, it might limit parallel job execution, right? Because to execute a job, you need a scheduler, you need some memory. If you don't have that, you might get you might get stuck. So what I'm going to use today, I'll be showing you into Azure, using Azure Data Studio, which is another free tool from Microsoft. We'll be using SQL Server 2019, CU2 on premises, and bunch of Azure resources, right? So that's all I'm going to show. So I am going to do a little bit of housekeeping here. Simon, can I stop my sharing and then share a different screen, or that's not possible anymore?
Sorry, Taiob, I didn't catch that.
Can I switch my screen for
Yeah,
sharing?
you definitely can. You can stop sharing and then you can reshare again.
Okay, thank you very much, because I really have a little bit of issue this morning. I don't know why. I tested everything last night, but I didn't expect this. So just give me 1 minute. Okay, good. Let me know when you can see my screen again.
I have added it to the stream. Everybody can see it.
Okay, awesome. So, technology always, catch us in a, I tested this last night, and as you can see, this has been, running for a while and it's not working, but I have some workaround, so you won't be frustrated. So before all of you came online, I got up a little bit early. The reason I did this, because as you can see in the top, I said, this can take 40 to 50 minutes, right? And we only have 40 minutes. So I did set a bunch of stuff already. So you don't get, feel like, you don't know what I'm doing. I did. So I said demo starts here, right? So I'll show you. Okay, I should probably start using another browser. Yeah. So I'll show you what I already, already created, right? So that way we can use those, and I didn't have to deploy everything when you are watching me, right? Because that's going to be, that's not going to be very, very nice. So, okay, so can I bring this into this screen? Okay, good. So before all of you came online, what I did is I created a resource group called SQL Agent Demo. And under that, I created a bunch of resources, right? A bunch of Azure SQL databases, Azure SQL Server. I also created a automation account. I created a runbook. I also created a function under a function app for this purpose. So otherwise, we don't have enough time. So let's get it started. So the first one I talked about is a linked server, if you remember. So I will be using a on-premises SQL Server 2019 server that's sitting in my laptop that I'm using for this presentation, right? So let's do a connection. And this is strictly on premises running in my laptop. I want to use this resource to do some maintenance against one of our Azure SQL database, right? So what I'm doing here, I'm first creating a database in my own premises and a table just to hold some data. So I'll be collecting the database size, right? So now some of you might get frustrated, like, we've been listening to you for 20 minutes and you said, you're going to show us some cool stuff. You're just showing us how to collect the database size, right? The reason I wanted to keep it simple is it doesn't matter what code I'm running against this, right? The concept is you can replace my code with anything. You want to do index maintenance, you want to whatever you want to do. You want to purge your old data, you want to collect some baseline, you can just replace it, right? But just try to grab the concept. So here what we are doing, we are creating a linked server. And if you see this, this is a Azure SQL server name, and that's a database, right? We'll be pointing our linked server to that. And if we go to the here, this is the server that we are pointing to. And in that server, we have a bunch of Azure SQL databases. So we'll be using this one for this demo. As you can see, I also have Elastic Pool, and I have 4 different databases. So we created a linked server. And now what I'm saying, using this linked server, using Open Query, bring this data set and save it in my on-premises SQL database. As I said, if you do not like what I'm doing, if you think it's too simple, delete this code, replace it with whatever you want, right? That will do the trick. So let's run this. And now if we look at the result set, as you can see, it's today's time. My time is 7 o'clock in the morning. This is UTC. It went and collected the size of the database, right? Now, you might say that, I don't want to bring my Azure SQL database, information to on-premises. Can I save it over there? But I want to do the compute in my on-premises SQL server, right? We can do that. So now, if we connect to the cloud one, to our Azure SQL database here, I do not want that database. In Azure SQL server, you cannot say use database name, so you have to be careful. You always have to be in the right context with the database. So there I'm going to create a table to save the database size. But now, switching back to the on-premises, I can use the same link server, but this time I'll be inserting into the Azure SQL database table, right? Not bringing it to the on-premises. And that's done. So now if we switch back again to, I know there's a lot of back and forth, and if you don't follow me, okay, someone is asking for a script. I'll show that. So I haven't shared this yet, but I'll show you. So now this table is sitting in the Azure SQL database, and I'm pushing it there, but I'm using my on-premises compute. Now this is all well and good, right? What happens if someone has 1,000 Azure SQL database? Are you going to create a linked server for each one? Probably not practical, right? So I'm going to take it one step further. And as I said, I could not connect through this. I do not know what happened, but I have a workaround. So I'm going to bring a PowerShell ISC. I don't use ISC anymore because I think Microsoft has stopped developing this. So I'm going to make it a little bit bigger so folks can. Normally, I don't use this for demo, but I do not have a choice here. So just want to make sure I'm still in the right context. Hopefully, I am. And then I have a bunch of variables that I'm going to use, so I don't have to type this every time. And these are all in the notebook. Now, what I'm going to do, instead of doing a server by server and using link server, I'm going to use some PowerShell code. And in the interest of time, I really cannot describe everything. But if you have a, if you need more explanation, please let me know. So what I'm going to do, I'm going to go to my subscription and so find out all the resources. So the way the Azure hierarchy works, you have your tenant, and then you have your management group, you have your subscription resource group, and you should have your resources into the resource group. So depending on where you want to start it, you can start it at your tenant at the root, go through all the management groups and come down. Start wherever you want. So it will go and find all the Azure SQL Server, all the databases, and it will collect the sizes from all those in one go. So I do not have to do one by one, right? So I'm taking it to a step further. As you can see, it's collecting results from many different databases. Before we only collected from one. And now if I run this, as you can see, we only had one record, and now we have a bunch of recorded, right? So we went and, as you can see, I have 2 different servers, a bunch of different database name. It went and collected all the information. Now to take it one step further, I ran this by hand, right? Now you might not like it, right? You might say, am I going to sit there and, run all my maintenance jobs by hand? No. So we talked about Windows Scheduler. So if I want to schedule this same script once a day or whatever you need, I can also leverage Windows Scheduler. So this is and you don't have to use Windows Scheduler, there are other schedulers, like at my workplace, we use Tidal. You might have other softwares for that. So whatever works for you, as long as, any scheduler can work. So here, what I'm doing here is, let me enable this. I have it scheduled every day at 11 a.m. to run, but I can also say, run it manually right now. It's actually calling that PowerShell function. So you can have this set up either in your on-premises, in a Windows server. You even don't need a SQL server anymore. So if you have hundreds of Azure SQL database and you run your PowerShell code and then use the Windows scheduler, schedule anything you want to do, right? And if you say, I do not have any data center, get IIS VM in Azure, and you can do the same thing. So let's go to properties. We should be able to see the history here. Oh, history disabled. Why? Enable all task history. Cancel. Now it's not responding. Let me go back and see if it did the work or not. So our last one was 11:04. Okay, it did. So it did collect again, as you can see here, right? 11:06. So that's another way, right? So try to get the sequence. So first we started with one single database using link server. Then we said, that's not practical if I have hundreds and thousands. So we jumped into a PowerShell code looping through, but we have to execute it manually. We don't want to do that because we want to, control our whole state automatically. We don't want to sit in front of a computer 24/7. Now we use this scheduler. So put any questions, comments if you're not following through, if I'm going too fast. So you saw this. So let's go back to here. And I also have XML code. If you want to create that Windows scheduler job that I just ran, you can use this, this XML. So the next we'll move to Azure Automation. And I normally do this live because this talk normally takes over 75 minutes, but because of 40 minutes, I ran some of this stuff beforehand for you. So let me go to Portal and show you what I mean by this. Automation account also has many other features. People use it for many different reasons. The heart of this is a runbook. And, runbook itself can be a whole 1 hour talk or can be a 2 hour talk. I'm not going to get there. There are different kind of runbook. As you can see, this is workflow runbook. There is regular runbook. There is a PowerShell based runbook. There are GUI based runbook. So again, we don't have time to go there. But if you want to start using runbook, like the one I'm using right now, I did not write that from scratch because somebody already wrote and shared, and they're okay with people reusing it. So don't feel bad. Go to Browse Gallery. There are a bunch of runbooks already written by community Microsoft engineers. Use those. And, I'm not saying just copy and start running it in production. Make sure you test it. You're comfortable with it, right? So again, I'll be using one here. And if I go to the edit, I can show you. And just to make sure that I make it very clear that I did not write this by myself, I put some notes here that I copied it from System Center Automation team because they published it and they have no reservation people using it. Now, again, for the interest of time, I'm not. Let me probably this is too small. I'm not going to go through all this, but basically we are declaring some variable. This is important here. I put fragmentation percent is 20%. Go and rebuild my index. But please, I want to make this absolutely clear. I'm not advocating anytime you have an index with 20% fragmentation, go and rebuild it. No. In fact, there's a strong debate in the SQL Server community that should we be even rebuilding our indexes anymore or just update stats. So I'm not going to get there. You decide for your, for your own, for your own environment. Shantar said, can we create link server from one Azure SQL with another Azure SQL DB outside the RG subscription? No, you cannot. Azure, and I'm strictly talking about Azure SQL database, right? You can see the question in the screen. So Azure SQL database itself does not allow linked server. There are, for refresh purposes, if you want to bring your production database a copy to non-production, there are commands that you can do, and you can go across subscription. If you need that, let me know. But if you're trying to do a maintenance, or I'm showing you from one to another, there is no way. No, you cannot do that today. For refreshes, you can. I do that. Let me know if you need that, if you need some tips there. So again, coming back to the presentation, I'm not advocating at all that you do this, right? This is strictly for demo purpose, easy for people to consume, and I can show it easily, so I choose this. So before we do this, let's go, and I have a run book that's called test run book. And again, I ran some of this stuff, because of, just to want to save time. So this is, again, in Azure SQL database, I created a table. I inserted a bunch of records, and then I, purposely created some fragmentation, right? Just so we can do this demo. So right now, you always have to be in the right database context. So keep that in mind. So right now I have this, this 1,000 records. I did update. So let's see how is the fragmentation. As you can see, it's right here. It's 98%, right? Now we'll go and we'll test this. And you can schedule this. You can save it because, we are doing this live. I'm using the test pen, right? You must. I should not have to, because I'm not sure why I'm getting this pop-ups, because I have default. I hard-coded the default values just so I don't have to type this during demo. Okay, so it says completed. I'll take a look later on, but let's run this now. Now look at the fragmentation, less than 1%, right? So I use this notebook to do some maintenance against my index. Now, if you don't like it, if you don't want to do this, you just just want to do updated stats, just replace my code with updated stats with, whatever interval or whatever modification percent you want. Hopefully you get the idea. I don't know why I got this, but I'm not supposed to get this, but I'm not going to troubleshoot this right now. We still have 32. Okay, good. So we've done the automation. And for the run book, if you want to copy my code, the whole code is right here. So you can just create a dummy notebook, replace the code with this. Of course, you have to make sure when you do this that you have this resources set up correctly, right? If you don't have this, if you have different name, make sure you replace this, and that should be obvious. So let's go down. This is just going to keep me in track, so I don't. Okay, so let's demo Elastic Job Agent, and then we have Azure Functions. So I'm going to switch to Management Studio. I know I can do all this from here, but it's a lot of back and forth connecting to different servers and databases, so it's just easier. So here again, what I did here, up to line 89, I already ran before all of you came online, just to save time. And up to line 89, and I put enough comment here, so hopefully you can follow along. So it's pretty much creating the security, right? So because I have a server named job server where I'm going to be holding the metadata, and I'm going to be creating my jobs and but run it against the target server, right? And bring back the result and all that. So you have to have the right permission, as I said before. That's what. So I'll be using credentials, and and then I already did all this. But read the comments before you go further, and then if you have questions, let me know. So the first one, we have to be in the job server, and I will be in the job database. Now, before I even do this, I want to show you something here. You remember I had a slide that I showed you all those system objects. Some of these you are familiar today. If you go to job database, some of these, if you go to MSDB today, you will see some of these. Let me double check one thing. If I have turned on, I might not have done this, so that's why I didn't see some of the stuff that I was expecting to see. Hopefully this doesn't take very long. Yeah, I was expecting to see some more system stable. So this is what you turn on your Elastic Job Agent. You give your resource group name, server name, your database name, and you give it, then whatever name you want to do. Now it is going to go, and you notice that when I was checking, I did not see anything here, right? So now I should be seeing some stuff here. Not yet. I should have run that before in the interest of time. Hopefully it finishes quickly. Otherwise, I'll move on to the next demo, let it finish, and we'll come back. So many of you ask, where can you get this code from, right? So let me take this time to show you. And don't get it now. I'm going to refresh this repo later on because I made some modifications. So just search SQL worldwide. When you go to GitHub, under presentation, you will see Azure SQL Database. Where is my SQL agent, right? So if you go there, and again, I haven't, last time I touched this 4 months ago. So give me like, a few hours, I'll refresh it. Then you can download all this stuff that I'm showing you. Download it. You don't need any permission. It's in, it's in open repo. Use it, modify it, give me feedback. If you made some improvement, let me know. If you see any error, you don't like it or whatever, just let me know. Okay, so that finished. Now you see these tables got created that we didn't see before. So that is what happened when you turn on Elastic Job Agent against a database. And I'm sure there will be more store proxy here that was not there before. So let's move on. We have 7 minutes. So now we have all the things in place. We go to job database. The first thing is I have to create a target, right? Where this job should run against, right? So I have to create a target. I'm just giving it a name right now. And now I'm adding this server as a target using my credential that I created before. And now we can go and see the details of the target, right? The one that we created, right? So I'm not going to read this, but you can see if you want to know all of your target and what resources are in each target, you can use this commands. You can also exclude a database, right? So I added the whole server into the target, but I don't want to run my code against all databases. I want to exclude one. I'm not going to do this in the interest of time, but I put this here. And now I'm creating a job. This is just a shell. if you notice that this job is not doing anything, just a name and a description, right? So at least, if someone is bored with, SQL database size, so I put some different code here and read about this. This job step is going to collect the output from here. So when as probably, I hope all of you know that during many DMVs has collection that get reset during a restart. So if you want to collect this, plus, this DMV only keep it for about, I think, an hour, because it collects every 15 seconds. If you want to collect this for a longer period, you can use this to save it. But again, just try to grab the concept. Don't worry about what it's doing, right? So now I'm putting a little bit more stuff into my, making the job. And as you can see here, there is an output variable. So what I'm saying is you grab the data from this DMV, but dump it here, right? Into this server, this database, this step. Could I have used the same database? Yes, I could. But normally at my workplace, the DBAs, you want to keep your stuff separate from your, other things, right? So now my database, my job is done. If I want to see all my jobs, right? This is a command that I can do. If I want to see the details of my job, you can also do that, because I only have one step. There are a bunch of other things. So now I'm going to start the job. And if you notice, we have this store procedure today on premises, right? SP start job. And I'm doing it with the name. If you want to do it with the ID, you want to grab the ID, you can be, you can become fancy. Now, the jobs are running. What's the status, right? We can see this. These are still waiting. These are in progress, as I said, because now all succeeded, right? Now I'm going to the warehouse where my output is saved and see the result of my job, right? So it ran successfully. As you can see, it brought back to those data from all those servers, all those database, all those DMVs, because in Azure SQL, some of the DMVs are pushed down to database level, right? Because there's really not a server context. You should just, train your brain not to think that way. So now, again, we only have 3 minutes, so I'm not going to run through all this code. If you run into any issues, get back, because there are no questions. We are actually in the question and answer phase, the last 5 minutes. So I'm just moving on because I do not see any question. The last one was from Santosh. If I see any, I'll stop and, but I want to use my 3 minutes that I have. So the last thing I want to show you is a function. And hopefully we have time and we can. So I have a function app. And again, I put enough code there for you to set this up. So I'm not going to, read all this. I'm instead going to go there because of my time limit. I created a function called index maintenance. And if we go back to here, we're going to use the same thing, test run book. So we see the fragmentation is good. Let's make it fragmented again for the interest of the demo. We'll never do this in our workplace. We know that. So it's again 98% fragmented. And this is a function. I have this code. And the trick here is to use the service, the app ID for your credentials. So again, we don't have time, but that's critical. And I put enough resource here, so so hopefully you should be able to follow this. So now we are running this. We are saying the same thing what we did with our run book. We said, this index is fragmented. Can you go and fix it? As you can see, it was 98%. Now it brought it back to 0. So I'm not going to go to the full mode just to increase this. So just few things here, right? So we talked about multiple options. Do I use all at my workplace? No. And do I have a preference? Yes, I do. I don't want to give it to you because I want you to figure out what's perfect for your, your environment. I actually was heavy on Runbook. I moved to something else, it's just because it works better for me. There's multiple languages, right? I showed you PowerShell, T-SQL, .NET. There are other options. You have Python. Based on your environment, what do you need, use that. Know your limitations and know how can you scale this out. Think about where your company is going in 2 years, 5 years, and 10 years, so you don't have to redo this, right? So again, I think we rushed a little bit, but I also put a bunch of resources here. So these are all URLs. You should be able to go and do those. So my last minute, my contacts again. And again, thank you to all of you who joined. Thank you, Simon, and the whole team. Runbook and functions are saying no, Mirza. Runbook is a separate service. It's called Azure Automation. Function, I used it using Function app. These are totally two different Azure services. They are not same. So, again, what I was saying, thanks to Simon and the whole team. Thank to all of you. If you didn't join, this conference doesn't happen. It's everybody's contribution, right? And I'm really honored and glad that I could come back on the second time. Actually, I'm wearing the C#. You couldn't see the logo, the shirt that Simon sent me last time. So I made a point last night to so that I wear it this morning. So thank you again. Please, if you have questions, use all my like Twitter, LinkedIn. Send me questions. I know we have to rush through this. This is a big talk. I try to, compress it, but I absolutely make sure that you can use it, right? Because it's useless waste of all of our time if this really doesn't help you at your workplace. So
that was absolutely great, Taiob. I mean, you covered the entire on how you can go and automate your SQL Server maintenance, also including how you can go ahead and replace the SQL agent. So that was absolutely great. And I see all the questions that we have got. You have already covered it. There's all one coming from Mirza saying, which one is recommended for maintenance plans?
So again, Mirza, when you say maintenance plan, right? Are you talking about do you do like DBCC check DB? Are you doing stats updates? Index maintenance? You don't need backups. Backups are automated. And that's why you didn't see the backup on my slide that I had a couple of ellipses, right? Because backup is a big thing we use SQL Server Agent Job in Azure SQL database there. Again, that's why I didn't want to pinpoint a solution. That's why I showed you a bunch of those. I want you to figure out, what works best for you. It absolutely will differ from, what's your security model, how is your resources even set up, right? From your tenant, your management groups, your subscriptions. These are big topics. All those will dictate many of the things. So because you will get blocked, your network security team will block you in all the way, and they're doing it for good reason. I'm not bad mouthing them. Trust me. You see in the news every day people are getting impacted. So it has to be tightened absolutely, but you have to work through that, and which is for all of us. If my company is ransomware, block everything, right? I don't have a job tomorrow, right? Because they cannot make money. So I want you to figure out that what's good for you. But if you have a specific question or compare contrast between the two, absolutely, I'll be happy to help you out. Reach out to me anytime. Like I said, I have a full-time job. I have other commitments. I have 3 children, but I'll get back to you. That's guaranteed. Doesn't matter if it's 2 or 3 days.
No, that is absolutely great, Taib. I know you are very active in the community and you just find ways to contribute. And thanks for tuning in. We're coming in branded, actually. I couldn't see that. I thought it is the C# t-shirt.
Okay, because of my camera setting, I didn't want to. Oh, yeah, I made a point last night. I put it aside. I never used it, actually. I said, next time I'm going to. But thank you for that.
Thank you so much, Taib. It's always really lovely hosting you. We would love to have you back whenever we do it next time, maybe next year. Hopefully in US or maybe in Europe in person. I would love to have you there. And I think you've answered all the questions, right? So any final thing you want to plug in before we move to the next session?
No, I'll just say, keep learning. I'm learning. The Azure is huge, changes every. If I don't go to a page or a service after a few days, I get like,
it changes a lot.
Like this morning, I tell you, like my Azure Data Studio would not connect. I was online last night till 10 o'clock. Everything was set up, rebooted, updated. It's not connecting for 2 hours. I got up early morning and I don't know why. So things will happen. Luckily, I use the ISC, to do the demo. So things will happen. Keep learning. And again, like this conference is for free. I cannot believe how you do this, bring this to thousands of the community. And thank you for doing this. This is nice that, people can just learn without paying for it in their own time. They can watch recording and all that. So thank you for your whole team and, your boss, and I know he's in, I don't know how he does this,
Yeah, me too. I don't know.
Amazing.
Sometimes I ask him, he would just ignore it, but I don't know how he does it too. But I want to thank you all, to all the speakers. There's no way we can pay back in any way. So you all just come and give your time. Some people are giving sessions at late night. You're giving early in the morning. So all this event is all because of the speakers that you come in and support the events. I really want to thank everyone, you and out there. And as I said, I would love to have you back. And Taiob, thank you so much for accepting the invitation. Yeah, see you soon and have a nice day ahead.
Bye.
Bye. Take care. All right, with that, we move to our next session. You just learned about Azure SQL database, where's my SQL agent, some automations, or how you can, replace your SQL agents. And we now move to our next session, that is again on SQL Server and Azure. And the topic name is very interesting, the age of reason. But before we go there, let's play a minute video from our partners. That's by ScriptRunner.
ScriptRunner, the #1 for PowerShell management. We get it. You were hoping that PowerShell would save your day, but you figured out that it is not user-friendly for non-experienced colleagues. Managing the increased demand on IT is a growing challenge, and running scripts manually is still very time-consuming and complex. Welcome to ScriptRunner, the #1 for PowerShell management. ScriptRunner runs on PowerShell scripts. It combines everything you need to efficiently manage and automate your complex IT infrastructure. With ScriptRunner, you'll be able to make it easy for your team to perform administrative tasks without any knowledge of PowerShell, have a transparent overview on all PowerShell activities, and most importantly, free up your IT resources for more relevant tasks such as innovation and development. Download your free trial now and unlock the power of PowerShell.
All right, that was a quick commercial from our partners. Now we move to our next session. That's by, I hope I say his name. I'm really sorry, I may mess it up. It's Christophe Laporte. I hope I said that right. He's going to talk about SQL Server and Azure at the age of reason. So without any further ado, let's invite him to the Cloud Summit 2021. Hi, welcome to Cloud Summit 2021.
Thanks, Simon. Thanks for having me here. How are you?
First, I'm doing great, but first I need to ask you, how do I say your name?
Okay, in French, that's a little bit difficult, but it is Laporte, the door, Laporte.
Oh, Laporte. All right. And the first one is, okay, Christophe.
Okay, so let's go on.
All right, so I'm adding your screen to the stream. Everybody can see it. And next 45 minutes is all yours.
Perfect. Thank you very much. Hi, everyone. Thanks for coming to this session about SQL Server and Azure. Just a few words about me. As you see before, I'm an MVP. I'm also certified on SQL Server. I'm a certified master, and I'm also a certified trainer since 2000 right now. I start working on SQL Server in the previous century. It was in 1997, and it was on SQL Server 6.5 on Windows NT 4. And as you can hear that, I'm French, I have a nasty French accent, so I'm sorry about that. So once upon a time, SQL Server, at the beginning in 1989, the first release of SQL Server appears, and it was working on OS2. It was just a project to port Sybase on OS2. And after a few years, in 1993, there was a first version of SQL Server on Windows. It was on Windows NT 3.1 at the moment. And in 1997, it just evolved with SQL Server 6.0. And that's important because it was the end of the collaboration between Sybase and Microsoft. And 1 year later, SQL Server 6.5 appears on Windows NT 4, and it was the first release that provided clustering, failover clustering. In 1998, SQL Server 7.0 arrives, and it was the end of the source conversion from C to C++. And in 2005, it was a huge release of SQL Server 2005, because it was the end of the complete revision of the old Sybase code. And if you remember the GUI, the management studio at this moment, it was very, very different than the one we had in the past. So 2005 was really a key in the evolution of SQL Server. In 2008, SQL Server of the version 2008 was coming, and at the same time, Microsoft announces Azure with some data services. 2 years later, we have SQL Server 2008 R2 and Windows 2008 R2 also. And we were wondering if virtualizing SQL Server was the right choice. Should I choose Hyper-V or VMware? It was VMware 4, yes, version 4 at this time. And we still were wondering if it is a good choice to virtualize SQL Server because of the performance, because of the infrastructure, and so on. But in the meantime, Microsoft released some cloud services, and SQL Server was one of them. The first release of Azure services was having a kind of SQL Server fully managed. And today it has evolved a lot, and we can run some application across multiple clouds. That means that you can have some business on Amazon, GCP, or Azure. And from Azure, you can manage all your services. You can also manage services on-prem and at the edge. Azure is a very, very large ecosystem. You have more than 2,000 products and cloud services, and you have a lot of regions. It means that you can host your application, host your data in more than 68 regions at this time. So the question is, why should I run SQL Server on Azure? Just because SQL Server on Azure has a lot of advantage. The first one is Azure has a lot of region across the world, the more region than other cloud providers. And that's a fantastic playground for SQL Server, just because Microsoft is owning the code of the source code of SQL Server. It means that if you want a managed service, like a DB as a service, it's a program as a service, a PaaS offer, that's not a do-it-yourself implementation of SQL Server on top of some virtual machine. Microsoft is able to transform the code of SQL Server to make it run perfectly in a managed environment. And the features are available on Azure first. It means that when Microsoft decided to add some feature inside SQL Server, it's first available on Azure, and after it becomes available in the next release of SQL Server on the retail edition. About the offering, Actually, the first offering, it's about containerization. The container, SQL Server is able to run inside container. From SQL Server, from SQL Server 2017, we were able to run SQL Server inside Docker. And with SQL Server 2019, it was supported also on Kubernetes. But the fact is, running SQL Server inside the container is a great opportunity to create some modern applications. We have different flavors of container on Azure. The first one is Azure Container Instances. It's the easiest way to go to containerization. Why? Because we don't have to worry about the cluster, the Kubernetes cluster on Azure. We don't have to deal with storage, with memory, with compute resources, with networking, and so on. And that's just perfect for dev, test, or CI/CD scenarios. To me, I would not use ACI for production purpose, just because the billing is not really appropriated, and I prefer running my production container on Azure Kubernetes services, but it is still possible to run it on ACI. I prefer AKS. Why? Just because that's a fully managed cluster. It means that if my container fails for any reason, it will be restarted instantaneously with the cluster. The other reason is if one host fails, another host of the container will run the same container, the same database. So it's a kind of failover cluster, a failover cluster instance. That's exactly the same behavior that we had with an FCI. So Azure Kubernetes Services is a great opportunity to run a container with SQL Server. And the last one, it's on small devices like a Raspberry Pi, for example. You can run SQL Server inside the container on a Raspberry Pi. The specific edition of SQL Server is designed to run some time series and data streaming capabilities like other databases, but using SQL Server is very interesting because you can push very easily those data from your on-prem or edge computer, your Raspberry, to Azure, and you can make some reporting on Azure, for example. So the container are really the second version of the virtualization, and I bet that in the future we talk more about containers than we talk about virtualization. That's really the next release of virtualization. Another offer is called Azure SQL, but Azure SQL is just a brand for many SQL Server managed services. The first one, it's virtual machine. Everybody has heard about virtual machine. There is nothing new there, but using SQL Server inside the VM on Azure has a lot of benefits compared to other competitors. For the use case, that's very easy to take your database from your on-prem environment and to lift and shift this database on Azure, just because that's exactly the same retail edition of SQL Server. And you've got access to the OS level. So if your application or if you need to have access to the OS level of your database, of your hosting system for your database, that's very interesting to use a VM. Also, if you need a lot of resources, that is to say, for example, memory or CPU cores or high IOP throughput, that's very interesting to use SQL Server inside the VM, just because in the past I built some VMs with 200 or 400 cores and up to 11 terabytes of memory. That's very interesting if you have this kind of requirements for your workload. A VM has, by default, a kind of high availability. It means that if your host crashes on Azure, Microsoft is responsible to run your VM on another host. So you are protected from the hardware failure. But if you want to protect your database from failures, you can also use always-on availability group or always-on FCI, failover cluster instances, as you make on-prem. That's exactly the same technique, the same behavior. And that's very interesting because if you want to lift and shift your database from on-prem to Azure, you can use availability group. You create a secondary replica on Azure inside the same cluster, or maybe a distributed availability group if you want. And you can leverage all the potential of Azure by simply making a failover of your availability group. That's very, very interesting for some migration scenario also. For the Azure failover cluster instances, you have many choice because the core concept of the FCI is to have some shared storage. You can use storage spaces direct, for example, or you can leverage premium Azure file share or Azure shared disk to create your FCI. But that's more than a VM. Why? Because you have a pre-configured image with a specific disk layout. Remember, when you were on-prem, you were creating some specific disk layout with data, log, TimesDB, and maybe other storage available. Please have the same habits on Azure. That's very, very important. So if you want to configure the storage for your VM correctly, don't hesitate to grab a specific image that comes with many data disks. That's very important. And also, you have access to the resource provider. The resource provider is just a kind of piece of software that gives you the license flexibility. It means that if you want to switch from a standard to enterprise edition or the reverse to enterprise to standard edition, that's still possible with the resource provider. That's very, very easy to perform this operation. And also you have, of course, because it is managed by Microsoft, you have automated backup available. If you want, you can perform your own backup on the database, but if you want to rely on Azure backup, you can. It's fully integrated. And also, you can opt for an automatic patching on your VM. And the next, the last benefit of the resource provider is the monitoring. Since you are on Azure, you have access to a large scale of monitoring utilities, the basic one, and as we will see that in a few slides, and some more some more complex one with Telegraph VM. So using SQL Server in a VM is very, very easy on Azure. But you have a lot of choice of VM, and it might be complicated to choose between one of them. If you want a VM with 4 or 8 core, you have more than 75 VM in the catalog. Or if you just want between 8 and 128 gigabytes of RAM, you have more than 130 VMs available. So that could be very, very difficult to choose the best one. My advice is just to opt for some memory optimized VMs. And my favorite is EDS v4 because that's awesome. And using this kind of VM offers a lot of bandwidth with the IOPS and gives you a lot of memory. And in some cases, you will need some memory, you need some bandwidth for the disk, but you don't need a lot of CPU, a lot of compute resources. In this case, I just recommend you to test the constrained CPU VMs. That's very interesting because you have all the capabilities, all the resources of the VM, unless you are dividing by 2 or by 4 the number of cores, and then the license fees for the SQL Server. That's very, very interesting to leverage constrained CPU VMs. As far as I know, there is only Microsoft that offers this kind of VM flavor. Maybe other provider will come to that, but that's very, very interesting from a license perspective. The storage might be also difficult to choose because there are a lot of possibilities. We can use standard HDD, standard SSD drive, premium, and ultra disk. So that's just a kind of performance and size choice. So you have to look at your actual resource consumption, and you will find something corresponding on Azure. Also, you have some specific behavior like the disk bursting. It means that if you don't consume all the resources available for your disk, the bandwidth and the IOPS for your disk, you are just crediting some buckets. And once you need an extra performance for your disk, you will just get some credits inside the bucket, and you will go up over the maximum capabilities of your disk. And since I think 1 week, we have the availability to choose some zone redundant disk for the storage for your VM. It means that you are more resilient to some specific scenario in case of a zone crashes inside the Azure data center. You can quickly move to another zone and to restart your business. You can also use some Azure Premium File Share or Azure Share Disk for the FCI. You can use some blob storage, create database to URL and so on. And you can also use some NetApp files. So you have a lot of choice for the storage layer. But the question is, what about the performance? To me, that's very important to choose some VMs that has the SSD local storage, the ephemeral disk available, because we can move the TimeDB database on this specific volume. And that's very important because the specific volume is local to the host. Okay, if your VM has to move to another host, you will lose all the information. But for the TimeDB, that's not very important because the TimeDB database is recreated each time you start SQL Server. So moving the TimeDB database to this specific drive is very, very interesting for the performance. You can also use this one for the buffer pool extension. Buffer pool extension, which will allows you to write information inside a file, a local file, with very, very low latency and high throughput. And instead of looking for the data inside your data disk, you are just looking for the data inside your buffer pool extension. That's just a kind of slower memory. And you can also leverage the host caching capabilities of Azure VM. It means that you can write the information to this drive, and after, under the hood, the VM will write the same I/O on the real volume you have attached to the VM. So that's very, very important for the performance. That's a kind of best practice to prefer SSD drive to attach an SSD drive to your virtual machine. But there are some limitations. The first one is that you cannot add an infinite number of drive inside your VM, and your VM has some IOPS and throughput limitation. But you have two kinds of limitation. You have the cached one and the uncached one. The cached one is very, very specific because it's related to the local drive, the local storage, the ephemeral disk you have inside your VM. And the uncached drive and the uncached limitation are related to all other volume attached to your VM. So if you want to get the best performance, you have to deal with these two kinds of limitations. The first one on the uncached and the other one on the cache. You can, for example, put some data, the log file on uncached disk, and maybe if you are performing a lot of read on your database, you can use some cache volume for your data disk with the read option, for example. So that's very interesting because you can go very, very far in the performance with this kind of scenario. But please don't forget your on-prem habits. It means that don't hesitate to split your database in multiple file group or multiple file instead of having a single drive hosting everything. So I prefer don't use striping. It means that I don't want to make a RAID 0 or a RAID 5 with all my data drive, but I prefer using simple data drive and file group instead. And of course, you have to split data and log at the same you are doing actually on-prem. Okay, the next offering of Azure SQL is managed instance. A managed instance, it's really the easiest way to lift and shift your database for a managed service. And a managed instance is fully managed by Microsoft. It means that you don't have to worry about the backup, the patching, and so on. But you have the full control over your database and almost over your instance. It means that you have a dedicated instance. All your databases, multiple databases, can share the same real instance on Azure. It means that you can perform some cross-database queries. That's not possible with other managed services for SQL Server, but inside the managed instance, that's possible to perform some cross-database queries. You have also access to the service broker, the database mail, and the SQL Server agent. If you need those services, the managed instance is maybe the best option to lift your application and lift your database to Azure, just because you need no change or minimal change to the application, to the code of the application, just to change the connection string. That's almost 100% compatible with SQL Server. By default, you have no access to the managed instance from internet. There is a native VNet support with only private endpoint available, but if you want, you can expose, of course, the managed instance to internet. If you think about migration, to me, the managed instance is the best way to go on Azure. Why? Because you can use some native backup restore capabilities to go on Azure. You can perform some log shipping, for example, with your managed instance. So if you want to migrate, you just have to fail over after your log shipping, and it's okay to go live on Azure with a PaaS solution, not a VM. It's a PaaS solution. And that's the only way. You have to choose the server collation on managed services. If you want to use Azure SQL database, you don't have the choice of the collection for the server. Managed instance offer this option. But just a few words about the managed instance. It relies on the service fabric. It does not use any container technology. Right now, managed instance, it's only on service fabric, no containers. There are two flavors of managed instance, the general purpose and the business critical. On the general purpose, you can handle almost all the workload of your business. It relies on remote storage. That's a premium storage, but that's remote storage. It means that you have maybe 2 milliseconds or 5 milliseconds of latency. You have a single node. It means that if this node fails, the failover time, that is to say your recovery time objective, RTO, is almost 1 minute. And for the billing model, you can choose from single instance and instance pool. It means that you will share all the resources, the number of core, the CPU, the memory, and the disk available, the volume available between multiple instances. And for the business critical one, you have got a local, you have local SSD. It means that you have a low latency to go to access the disk, and your workload will be also very, very low in latency. Under the hood, you have some kind of availability group. That's the same technology. It means that the failover is very, very fast, less than 10 seconds. And you also have a read-only replica for free. That's very interesting because you can offload the reading of the for your application or for the reporting, for example. And in addition, you have 2 more hidden replica that will just allow you to perform some failover. The next offering is SQL Server, Azure SQL databases. That's just the way to build some modern application without wondering about CPU, memory, disk, monitoring, and so on. So Azure SQL Database, it's a fully managed services. That was the first one that was built inside Azure back in 2009. That's the smartest way to create and to develop some modern application. And you can create and deploy the database wherever you want in the world and in a few seconds. And that's very, very interesting because right now, if I am on-prem, I have to order some hardware, I have to receive the hardware, I have to plug, to configure, I have to install SQL Server, and then I can run my application. It just takes a few weeks. And if you are using Azure SQL Database, it just takes a few seconds to create the database and to go live. There is some built-in high availability. It depends if you are using some general purpose or business critical tiers, but by default, you have high availability, at least 99.9%. And the general purpose, it's a kind of failover cluster instance because you have some compute nodes that will attach the file that rely on Azure Blob Storage. So it's very, very easy to detach and reattach the database on another node. So the behavior of failover cluster instance provide you the high availability for the general purpose. For the business critical, just think about an availability group again. You have many VMs with local SSDs, and the database rely on these local SSDs. And with availability group technology, the data are replicated from one node to the other node. And once again, you have 4 different nodes inside your, I would say, cluster for your business critical Azure SQL database. As it is a managed service, you have fully automated backup. That's very interesting because you don't have to worry about the backup, but you also don't have to worry about the geo-redundancy of your backup. It means that there are at least 6 copies of your backup, 3 inside one data center and 3 over inside another data center, because that's 2 different regions. Not a zone, but a region. It means many hundred of miles of distance between each of them. So that's very interesting because in case of a failure of an entire region, you can spin up your database very, very, very quickly in another region and go live just after the restore. So the geo-redundant backup is very interesting. You are protected from ransomware because you don't have access to the files. And if you want to create a big restore, that's very, very easy by PowerShell or by the portal to create a database based on the backup of another one. There are some service tiers: general purpose, business critical, and hyperscale. General purpose, in the most case, is enough to run your workload. If you need low latency again, prefer business critical, and the business critical will offer you a free replica for the read-only also. If you have some requirements very, very specific with very, very large databases, it means maybe 100 terabytes, for example, you can use the hyperscale tier of Azure SQL database. That's a very, very different implementation of SQL Server because you have to split the compute layer just to perform your queries inside the memory, and the transaction will be stored inside a log service, and after, those transactions will be replayed on some page server. That means some SQL Server instances that just take care about the file of your databases, the MDF file of your databases. And the files are stored on remote data storage. That's very interesting. That's a very interesting infrastructure because you can scale out very, very easily from the IO perspective because you just have to add more page server. And if you want to perform some read-only workload, very, very intensive read-only workload, you can add some read-only replica on the compute layer. And this read-only replica will provide you a read-only access to the database. So that's very interesting from an infrastructure perspective. And I hope it will be available one day with the retail edition of SQL Server. Actually, that's not the case, but I hope in the future that will be possible. For the billing model, you can choose between the single database, the elastic pool, or maybe the serverless. If you are choosing the single database, it means that you will pay for some resources for one database. You consume, you not consume, that's up to you, but you are paying for one database. If you choose the elastic pool billing model, it means that all the resources you are paying for are shared by all the database you will put inside your elastic pool. But in some case, it could be very interesting for the financial optimization, just because inside an elastic pool, I can have one database that is used by people in Asia, and another database that is used by people in Europe, and another one for people in the United States, for example. It means that it's not at the same business hour, so you just will you are just able to spread the workload on different hours, and you are paying less, in fact, for the whole compute. And the serverless might be interesting if you have some very, very unpredictable workload. For example, maybe you will use your database, I would say 2 or 3 hours a day, or some days we don't use the application at all, but at the end of the month, you will consume a lot of resources. You can use a serverless because you are billed at the second for the compute you are using. And in case you will not use some compute resources, you are just billed for the storage. So that's very, very interesting to use the serverless. For all my demo databases, I'm using serverless. That's very, very interesting. You have a small delay when you have to start the database, but after that, you have the full power, and even you can have more power than an elastic pool or a provisioned single database, just because you can afford to add more cores in your serverless configuration. That's very, very interesting. If you are looking for HA or DR, you can have some local redundancy and zone redundancy. For the general purpose, the local redundancy is always maintained because the data in the log file are at the minimum located on some local redundant storage, LRS storage. So in case of a failure, you have multiple copies of your data file. And in every case, all the backup are on GRS storage. And if you want some zone redundancy, you can now opt in the portal for the ZRS storage. It means that if the zone is unavailable for any reason, you can switch to another zone and reattach the file. That's done under the hood by Microsoft. You can reattach the file of the database, and you can go ahead with your workload. If you are using the business critical layer, the service tier, sorry, for the local redundancy, that's okay because you have multiple copies of your database on the 4-node cluster. And if you have, if you want to have some zone redundancy, there is also a choice inside the portal to opt in the zone redundancy option. It means that every VM of the always-on cluster will be located in a separate zone, AZ, inside the Microsoft data centers. And the next topic, it's about geo-replication, because you can have HA inside a region or inside a zone, but if you want to have a copy of your database outside, you want maybe to have one copy of the database inside the US and one other in Europe and one other in Africa and the last one in Asia. That's possible with geo-replication. You can have up to 4 replica of your database using this kind of technology. The whole database is copied and is available as a read-only on several secondary regions. On top of the geo-replication, you can add some auto-failover group. It means that you will create some specific listener for the read-only access and the read-write access on top of geo-replication. And when you failover, you just have no change on your application, no change of the connection string, because Microsoft will deal for you with the DNS change, I would say, to directly access the secondary server when it becomes primary. So that's very interesting, because you are fully protected from a region crash in Azure. For the security perspective, that's very interesting to use Azure, just because you have access to many different things. The first one is all the data are encrypted at rest on disk, and also you can use some TDE like you are doing actually on your database. And also you can use some TLS and always encrypted to protect during the transport of the information. You can also create some private endpoint. That's very interesting, because you are hiding your SQL Server instance from the internet, and you can only access your database within a specific subnet inside Azure using the endpoint connection. And after, you can create some peering between different VNets, and you can create an express route from your on-prem network to Azure, just to be sure that everything goes under control and nothing is seen from the internet. All the capabilities of SQL Server as a dynamic data masking are also available on Azure. There is no issue on that. By default on Azure, you have just some simple checkbox to use to enable some auditing. So if you want to add some auditing on the security and all the T-SQL statements that are run on your SQL Server, that's possible from a single checkbox inside the portal. The monitoring is very, very interesting on Azure. I'm working on SQL Server since 1997 right now, and I used to face some performance issue with my customers, and usually they don't have any kind of monitoring tool. For some of them, they are just making some pings to see if the host is online. But from a SQL Server perspective, there is not a lot of monitoring. That's a pity, but that's the way it goes. And when you create some managed resources on Azure, that is to say managed instance, that is to say Azure SQL or VMs, by the way, you are getting some monitoring tools by default. And if you want, you can add more than that. You can add a simple VM, a small VM that will use the Telegraph agent. It will just grab the information from your VM, from your Azure SQL, to centralize all the information inside SQL Insight. That's very interesting to have a unified monitoring experience for the different flavors of SQL Server on Azure. And when we are looking at what is available on-prem with my customer, for example, I bet that they would have this kind of monitoring, because that's very, very easy to use, and you can find a lot of information with this kind of service. I encourage you to leverage the SQL Insight. Actually, it is in public preview, but as soon as it is GA, I will encourage you to use it. So my point of view as a DBA about SQL Server on Azure. Actually, the offer is really mature. If I go back, I would say 10 years before, I could not take the same talk. That was not possible. But actually, because of the performance, because of the HADR capabilities, because of the monitoring, the security, and so on, the offer we have on Azure with virtual machine, with managed services, even with container, that's the best we can have on for database for SQL Server. 10 years ago, it was not possible to have this kind of performance. We don't have any containerization also. But actually, I think SQL Server on Azure is the best place to run your SQL. From the migration perspective, you can even reach some kind of zero downtime migrating from on-prem to Azure if you are using SQL MI, donc managed instance, with some DMS or log shipping technology. Azure removes the repetitive and boring task you have to do as a DBA. It's almost 80% of your work time, maybe. But if you are removing the repetitive task to check if the backup are okay or not, you can highlight your skill for database tuning, for database design, indexing strategy, and so on. So it will just take the best of you as a DBA without taking your time with boring stuff. I started building cluster in the previous century, and really, you can believe me, that's very, very easy to build a resilient infrastructure right now. In the past, that was not the case. I have to build some cluster or geo cluster. I have to deal with the backup and so on. Right now, everything is done. My backup are available on different regions. So that's very easy to go ahead if one region failed. And also we've got some auto failover groups that will perform an automatic failover in case of a failure from one region, for example, and it will switch to another region automatically. That's just perfect. I don't have to worry about that. And that's what I'm asking for a cloud provider. From my point of view, no other competitor are able to deliver a service like Microsoft does for SQL Server. That's the best you can have on the cloud. Just because Microsoft is owning the code, the source code of SQL Server, so that's not possible that Amazon or Google can provide such a service from a managed infrastructure. If you want to have a VM, okay, we'll have approximately the same thing on different cloud providers. But if you really want to leverage some managed services, Azure is the best one. The question is no longer if you want to go to Azure or when you are going to Azure, it's just how. Because the how is determined by some choices, restriction on the platform, because of the IOPS, because of the memory, because of the volume of your database or the workload. But we have a lot of choice today to put SQL Server on Azure. So the question is just how you want to move. Is it a fresh databases with no data inside, or it is a migration? And if you don't want to go to the cloud, no worries. The cloud will come to you, because with Azure ARM enable, you can have dedicated hardware inside the data center, and this hardware will just run Azure, the same Azure services than you have on Azure hosted by Microsoft. You can have your containers, for example. You can have your Azure SQL.
It's time to wrap.
Okay, I was almost at the end. My position as DBA is not dead, clearly, because that's exactly the same skills and the new one. And the job is very, very attractive just because we have to deal with a lot of data. And in the future, I think by 2025, we have to deal with more than 35 million of terabytes of structured data. Okay, I think we are on time. As a key takeaway, yes, Azure provide a very, very mature offer for SQL Server, if it is in IaaS or container or PaaS services. That's very easy to deploy, very easy to monitor, and it's always evolving. It means that every single week you have to look at the change, the news on the blog of Microsoft and so on. So please never stop learning. Simon, any question?
Christopher, we don't have any question, but I have one question for you. But that's not at all technical. I see you had so many slides coming in just about 40 minutes, right? How long it took you to go ahead and make these slides?
Oh, that's a good question, because I had several talk on Azure and SQL, so that's just taking some slide in different presentation. But I would say that's maybe 10 or 15 hours of work. Oh. But all the slide will be available for download.
Thank you, Christopher. You know, that's a lot of effort that every speaker is adding to this session, and it builds up momentarily, right? It's not like, hey, you sit back and then you create from scratch. You have been giving sessions in different conferences. You pick out best out of those, and then you create the new one. So, Christopher, I know that was an absolutely amazing in-depth session, and I believe people watching it now, when we put it as an archived video, people definitely love it. Any final thing, Christopher, you would like to plug in before we move to the next session?
Thank you. Bye-bye.
All right. Thank you, Christopher. Thanks for joining in. We'll see you some other time. Have a great day ahead. Ta-da. Bye. All right. With that session on Azure SQL, we now move. We now move to our next session. That's on Azure ARM now with Bicep. When I read it for the first time, I found this title very, very catchy, and so as our team found it. And yeah, people have been saying thanks, Christopher. Christopher, if you can see it, people really love your session. Santosh says, thank you, Christopher. Great session. A lot of things to know. Iqbal says, thank you, Christopher, for the detailed overview and deep dive content presented in your sentence. I felt the same. There was a lot of content in his slides. But with that, we move to our next session. It's by Tushar. Tushar is a cloud solution architect, and I have known him for a while now. I love this live show that allows me to connect with the people I have known for so long. So without any further ado, let's invite my mate Tushar from India. Hi Tushar, welcome to Cloud Summit 2021.
Hey Simon, that was a great intro, man. You refreshed all the memories.
Yeah, I saw the one that in the university, right? So it's been a really long time. Looks like you have changed your look. Looks very
it's like I grown a beard and like I'm trying to look some old over here.
What a great memories we've had with this Microsoft Partner Program. We're going to do a lot of chit-chat to share towards the end of the session, right?
Sure.
And I'm really excited and looking forward for your session. Feel free to go ahead and share your screen, and then you can go ahead and get started.
Okay, let me share my full screen over here because I don't want to hide anything.
You bet.
Okay.
Let me see.
I hope you guys can see my screen.
Yeah, Tushar, maybe you'd like to click on that hide, StreamYard hide will pop up. Yep, that's it. Everybody can see your screen. And next 25 minutes is all yours.
Thank you so much, Simon. And very good morning, good afternoon, and good evening to everyone who have joined in. And thank you so much for joining in for our Cloud Summit 2021. I see a lot of great line of speakers and great sessions getting delivered over here, right? Since like from past few days, like each and every day, I'm spending a couple of hours just looking at all those sessions, what all is getting. I'm also getting to learn a lot of things out of here. So I'll just in next 25 minutes share a quick things about Azure Bicep, as we discussed, as Simon mentioned, right? So basically, as Simon mentioned, my name is Tushar Kumar. I'm a cloud solution architect. Basically, I work more towards the infrastructure technologies, DevOps technologies specifically. And as you know, as you can guess from the line over here, right, we are going to talk about Azure ARM, now got Bicep. So even I don't got the biceps better ones, even by working out a lot, but still in Azure ARM, we have got Azure Biceps over here. So basically, when we talk about Azure Bicep specifically, right, so we need to take a step back and think about the infrastructure as a code. So when we are talking about infrastructure as a code, right, there are plenty of options that we have got at this point of time. First, if we are talking about Azure, so we have got Azure Resource Manager templates, our own favorite ARM templates. Also, we have got Bicep, which is a fairly newly launched service, which is getting matured by time. And also, like, I see a lot of transformation happening towards Bicep over here. Also, we have our Azure CLI. We have our own very favorite PowerShell, which we can do anything with and deploy all the Azure resources, configure our machines, and all those things we can do, all the great things we do with our Azure PowerShells over here. Now, we have our code SDKs. We can integrate it anywhere, any application. We can put our Azure APIs over there. We can put our SDKs over there, and we can simply overall govern the environment as well as deploy anything on the go as we integrate. Then comes the third-party ones, like coming from Terraform and Ansible pieces. So Terraform is a great tool that we have got where we can from the multi-cloud management perspective, right? When we are looking at infrastructure as a code, and when we are talking about multi-cloud, I preferably go with Terraform mostly because Terraform is great language. You can do anything and everything out of it, and combined with Ansible, you have got more power into it. Also, we have got our own favorite Chef and Puppets, where we can all the configuration managements and everything. So we have a full suite of tools that we have at this point of time that we can utilize while we are getting into our infrastructure code journey. Basically, at this point of time, since I work with a lot of enterprises at this point of time, and they are in each and every transformation that they are looking at it in terms of cloud, the main focus is towards the automation piece of it. And wherever the automation comes, infrastructure as a code comes, because unless or until you are not automating the first step towards the cloud, which is going to be your landing zone automation, which is going to be your application servers automation, you'll not be able to achieve your automation level, which you are going to apply on your actual apps, which is going to be consumed by users. So basically, what we have seen so far with ARM template, it has been great. And what we have seen, it is a first-class citizen. The first thing that comes in our mind, right? It's an Azure native one, right? It is tightly integrated with the platform. You have a very good repository available over there. You have a full access to Azure Resource Manager over there, and you are building everything on top of that. Okay. Second thing that we can easily plug in our desired state deployments. We can easily define a desired state, and we can put our ARM templates over there, and we can do repetitive deployments out of that. And as I mentioned specifically, right, it is basically idempotent. Every time you're going to do like a very good example of idempotent we take, like every time if you're asking to eat someone a piece of a cake, you are finishing it off. But when when it is an idempotent thing, it is repetitive deployment. You are just asking someone to see a cake. So there is no loss over there. Every time you are deploying the similar desired state that you want. Moving forward, if we are looking at the deployment timelines, specifically from the deployment timings, right? If we are any third-party tools that we go ahead with, any third-party areas that we see specifically, right? We see a little bit of lag because it is not that tightly integrated with the platform itself. So there, the basic benefit of ARM template comes in, since it is very tightly integrated with the platform. What you're getting is faster deployments. Also, CI/CD integration with Azure DevOps, if we are going and with any of the going ahead with any of the third parties as well. CI/CD integration with Azure platform is fairly simple and fairly easy that we can do. We get a lot of plugins out there which we can integrate it with, and we can simply put our ARM templates into our code repositories, and any point of time we can do the simple deployments over there. That's a fair scenario. It is quite extensible. We can take it from a resource group level till the point we are looking at the configuration of our SQL servers, or creating our Active Directories with all the desired state that we want to put in, with the very good integration with our PowerShell, and as well as bash scripts that you can put in with your ARM templates. If I look at the track deployment specifically, which is one of the features that I very admire from at ARM template side, so you have a full track of your deployment. So let's say we are deploying something on our Azure platform. At least we will get to know, okay, so and so things got deployed, and so things got failed, and also you get a clear picture. Okay, what exactly went wrong? You missed something in the versioning of that particular ARM template, or you missed something in the syntax declaration and all those things. So specifically, you get a clarity whenever you are doing a deployment with ARM templates. So if I move forward specifically, right, we were happy. We were very happy with our ARM templates. As you can see, we have been writing like thousands and millions of lines of our ARM templates, defining the local network, defining the application gateways, and all those things. But the thing is, where exactly it lacked. So there, basically, Microsoft decided to focus it on, because we faced some of the challenges. Microsoft also faced some of the challenges looking at the ARM template, because when we are talking about ARM template, right, I'll not call it disadvantages, right? I don't like that word specifically, but I was not able to find a particular synonym. Excuse my English over here. Okay, so basically, when we are looking at ARM template, the major disadvantage that I see, right, it is around JSON. Okay, so when we talk about JSON, right, so JSON was basically designed for machines to communicate between each other, right? And each and every one of us, it's not we got introduced with JSON just because of ARM template, right? It was at some point of time we were working with some client server methodology, and then we have seen there that some application is calling out their backend servers with the JSON template. So there was a lot of noise into that. So when you deploy, even if I go back a single slide, right, if you see, there is a lot of commas, there is a lot of curly braces, there is a lot of stuff that is unnecessary over here that got deployed. Okay, so basically, it's not for humans. It's for the machines to do all the stuff, machines to communicate with each other and let them communicate in their language. We are not interfering in them. So we will be communicating with the machines with our own language. So with all the noise that got introduced into the ARM template, specifically because it is from JSON side, right? What happened is it became very hard to read. So everyone whosoever is deploying, whosoever is creating an ARM template is having tons of errors around it. Let's say if you misses something, right, there is a whole lot of exercise that you need to do to find the particular error that you are facing. Also, if we look at from the verbose perspective, right, so for a single item, you have to write tons of lines. Okay, it's just a resource group or just a parameter that you need to define. What is there and what is like a big thing in that? It's just a parameter. We have been doing it in multiple programming languages as well. We have been defining variables in multiple programming languages as well, right? So why should we write multiple lines? Why should we write a whole hell lot of code just to define a simple thing? That's where we felt a disadvantage into it. And I don't know if you guys have ever get trapped into the nested and linked templates with ARM. What happened with me, I can share my experience as well. At some point of time, I was quite sleepy. There was a deadline coming, and I had to deliver a particular script, particular template around it. And I have banged my head almost around for 2 to 3 hours just because of one nested template, and it made it so complex that I was not able to refer back that where exactly this error is coming from. Maybe I was not able to figure it out at that point of time. That's a different case, but it made it a bit complex for us, nested and linked templates specifically. So from there, looking at these all disadvantages, right? Microsoft has looked into it. Microsoft, there was a project Bicep going on for quite a long time. And very recently, I believe last year only, Microsoft give it a special attention over there and took it as a priority. And now we are seeing a lot of traction with Project Bicep over here. Okay. So let's talk about Project Bicep specifically. So what exactly is Project Bicep? So Bicep is nothing but a language that we are talking about. Everyone call it as a DSL. So basically when we are talking about DSL, right? DSL is nothing but your domain specific language. So we have a specific domain that we are trying to address over here. And now we are trying to create a particular language which will help us out throughout the process of our deployments. Okay. So basically, what Microsoft did is they put a Bicep language on the top. And when we get into it, when we do a Bicep build, in the end, it is generating an ARM template in the backend. Once it is getting once the template is getting generated, what we are doing is we are getting into the deployment of it. Okay, which is again getting into the level of Azure Resource Manager. So basically, what an extra level of comfort that it is giving you. So just because it is tightly integrated with your ARM template, and in the backend we are utilizing our ARM capabilities over here, right? So anything and everything that is in GA at this point of time will be directly available for you on Bicep. Anything and everything that is in public preview, you can utilize it with Azure Bicep since it is totally integrated with the platform. Anything and everything that is in private preview as well, if you have access to that, I cannot comment on the access of your any services on the in private preview. But if you have access to that, you will be able to utilize that with our Bicep language itself. So what exactly is Bicep specifically? As I mentioned, it's a domain specific language designed for a specific purpose, and specifically it is very tightly integrated with our ARM, and that's why the way Bicep is operating at this point of time, it is giving you full flexibility for throughout your Azure environment. So if you look at on the bigger picture, right, it is nothing but a transpiler, we call it basically. So when we say transpiler, right, it is nothing but it is like translating your language, translating your whatever the desired state configuration that you are mentioning, right, into ARM templates. We will be looking at a live demo of that as well towards the end of this session. But basically, if you have worked with TypeScript, it is something similar to TypeScript, you can say it, because in the end, the code gets generated and it gets into the JavaScript level itself. So similarly, what happens over here is whatever you are doing, it is getting into the ARM template itself. What Microsoft has came up with, the authoring experience of Bicep template is way too easier than our ARM templates. So basically, when we talk about ARM templates, right, it is, as I mentioned, a lot of like complexity and ARM templates. If someone is starting with ARM templates, don't get scared. It is not that complex. I'm just trying to showcase that how Bicep is improving and how Bicep is making your life easy as well. So it simplified your authoring experience, and as well as you'll have a transparent abstraction. So basically, Bicep has came with multiple new functionalities. Like you can divide it with multiple modules. You can divide your code. We have been doing it with multiple programming languages as well, right? So we can divide our code specifically into multiple modules, and then we can reuse, and we will be able to achieve our state quite transparently. Okay, just a glimpse of it, just a quick view. So anyone who is currently doing ARM template deployments or creating ARM templates, right? If you can see over here, specifically just defining a parameter takes this much of complexity. Like you have to define the parameter, you have to put a colon, you have to put so many of curly braces. And if you lost track of one curly braces, and if you're doing it on Notepad, right, you will definitely bang your head just in parameter for a couple of hours. Similarly, the same thing, what I did is I created that in Bicep. So let's say if we have to deploy a parameter, it's just one param, just give the name, just put the string what you want to put in the end, and you will be able to achieve that particular thing. Same for the variable, as you can see, still one-liner, but we have a lot of noise over here. We do not want all these to be here when we are doing this particular coding. So just on a glimpse, we'll see the live action as well. So why Bicep is going to be used going forward, right? You say we are pretty much comfortable with basically our JSON templates, right? Why should we go ahead with our Bicep thing? Okay, so basically it is very intuitive and very easier to get started with. Okay, so anything that is that you are trying to achieve at this point of time and on your next projects, right, you should definitely give Bicep a chance to. Once you do one template with Bicep, right, I can bet on it. There is no going back, man. You have to stay with that particular one because it is quite easy. You will not face any challenges. What all you have been facing in ARM, and we have been seeing. I've seen a lot of customers. I've been seeing a lot of users as well complaining about how should we remove all the complexity that Azure ARM templates has. It is quite a modular one. Like you can create specifically the modules feature that it has. You can create multiple modules around your code, and once you whenever you want to call them specifically, like as we were doing as we were creating multiple modules in our Java and Python kind of languages, right? Similarly, we can create modules and we can utilize those modules and we can put it on our Git repositories, and at any point of time, if whenever we wish to use it in one of our projects, we can just pull it and we can put it in that particular code. The best thing is it is extension of ARM. It is not the replacement. So you cannot replace ARM with your Bicep. Okay, so that is the thing. So it is extension of ARM. So there is no need of worry. Let's say if you are using your current ARM templates that you have, there is in near future they are going to like it will be decommissioned, it will be retired. You need to upgrade it to Bicep. That is not true. You need to whatever projects that you are bringing in, right? You need to bring in basically Bicep. If you want to continue with ARM, if you are comfortable with it, that is well and good. But my recommendation will be just try once what exactly Azure Bicep has to offer, and definitely you will like it, and you are definitely going to use it going forward as well. Okay. Best thing is the integration with existing tooling. So when I say existing tooling, right, since being it from Microsoft product with VS Code, the integration is very seamless. And once you install the extension, right, I find it very easy. You just have to put your tabs and your hand on your space, and you'll be able to write the whole code. Just you have to put all the parameters that you need to put in and all the variables that you need to put in. You do not need to worry about a lot of things. The IntelliSense that is there, it is very good. And whenever you're deploying any of the workloads, right, the best benefit that you are getting with the IntelliSense, like let's say if you're creating a template specifically for maybe a virtual machine, creating a virtual machine, and it will totally protect you with something like this, that is going to be the curly lines. That, okay, this SKU that you have mentioned over there, that doesn't exist. And or maybe whatever the region that you have mentioned, that doesn't exist right now. So you might have to check that. So that level of integration here, we will find with Azure Bicep integrated with our Visual Studio Code. So as I was mentioning, right, do you need to start rebuilding everything? Is ARM going anywhere? No, ARM is not going anywhere. ARM is here to stay. We are going to utilize ARM in coming projects as well, but anything that is coming in, we will be writing that in Bicep. In the backend, it is going to be converted into ARM templates, and at any point of time, if you want that ARM as well, right, we can definitely utilize that as well. One thing I'll mention that Bicep is still in early stages at this point of time, and each and every day we are seeing a lot of improvements in that as well. Like, since if you ask me almost 7-8 months back, if you try to deploy a Bicep, the way you have to do is you need to do first a Bicep compile, you need to generate the ARM templates, and then you have to deploy the ARM templates. Now at this point of time, you can directly give a reference to Bicep template and you can do the deployment over there. Also, as I was mentioning, any new projects that is coming in, you can have Bicep onboarded for those projects, and you can get you can try your hands into it, and you are definitely going to love it. But the way it is going to be moving your existing templates, because what templates once created, right, it is not like you're leaving it there, because when we are doing a periodically upgrade on our templates as well with the specifically API versions or maybe some new functionalities that is coming in. So moving our existing templates will definitely make sense. Bicep provides a very basically you can find it as a Bicep playground over there, and also there is a command line tool available as well, so that you can convert your existing ARM templates into Bicep templates. Though I have tried it for the smaller ones on a bigger projects, like if you let's take an example of enterprise scale landing zone template, right? If you go ahead with that, right, you might face a couple of challenges over there. But when we are talking about this, it totally makes sense to move towards the new Bicep environment. Okay, so I'll just quickly see. We are going to see a quick demos around the Bicep. It is not going to take 1 or 2 minutes. I'll just quickly see what all I can show you. Okay, let me just quickly switch to my VS Code over here. So just one quick example over here, right? I was trying to create something around it, and if you go ahead with the JSON template, right, it's a simple JSON. If you go ahead with the hello world, it is so much of work. I'll show it in the Bicep playground as well. But creating a Bicep template, right, it is a very simple Bicep template. You just define your resource tags. You just define your resource location. It is a simple parameters defined. So see, you can see a simple parameter, what you're defining over here. It is the simple parameter is defined in a single line. And the deployment as well is quite easy. If I just, I think I have it already, just to save some time, right? So you just have to reference the Bicep template over here. You just have to give the deployment as a name. If you have done any Terraform deployment, right? Similar to that, you have to give the deployment a name. You have to point it to either a resource group or a subscription, and then you're good to go. You just have to run with your AG CLI, and you will be able to deploy that. So meanwhile, it gets deployed, right? I already have a AG submit, and we are deploying basically a storage account over here. I'll show you the Bicep playground. I know Simon must be pinging me around this, but definitely. So see, this is the Bicep playground. You just have to Google for Bicep playground, and you'll get to see this kind of page, right? So there is a lot of templates that is predefined over here, and it is not basically a Bicep templates we are talking about. It's basically both of your ARM and Bicep templates. So if you look at it on a deeper side, right, what you'll see, a 79 lines code is getting translated into somewhere around 44 lines code, and with a very less complexity over here. If you see this one, right, even my eyes are hurting looking at this one. But if you look at this, everything and every concatenation that you used to do within your Bicep, every variables that you used to put in across in your Bicep templates, right, it is quite basically what I'll say simplified over here, and you will be able to deploy that very easily. Okay. So meanwhile, I believe my storage account must have been deployed, and you can see all the storage account capabilities is here. Everything is mentioned, and everything based on our template over here, right? It is deployed. So I'll just quickly take the questions that we have. I believe I've been going very fast over here. So Simon, do we have questions?
Right, Tushar, that was absolutely amazing. I believe to me it looked like a Chennai Express for those who can. That was good. The couple of things that I could really relate from what you said is like, JSON is not meant for humans, right? To be honest, it's just like you giving me a CSV file and telling me I'm giving you a CSV file, but I'm not giving you an Excel. Now you have to process it on your own. You edit it on your own, opening with a notepad file.
Correct,
And
man.
I also don't like that. Whenever I have to write a JSON, I have to put first quotation, then a variable name, then again a quotation, then within inside you always have to add it. No matter how much intelligence the IDEs have, I always mess it up. So Biceps looks really promising. There's one question I want to ask. You did say that Bicep is an extension to your ARM template. It's not a replacement. Right?
Correct.
It's not a replacement. So is it like in the same, if I have an ARM template and in that same file, I can also write some Bicep code over there? Will that work?
No, basically it's when I say the extension of your ARM templates, right? It is just you can say a kind of orchestration we are putting on top of our ARM templates. So it's like your Bicep template gets translated into your ARM template, so you do not have to worry about all the JSON things, right? You just write it like you have a Python script that you're writing, right? And it is getting generated into all the machine level code, you can say.
Oh, that makes sense.
So like Python to assembly, we are translating. That's that kind of level of simplicity that we are bringing in over here.
That's perfect. It's just like people who write on front end like Vue and React, or at the end it gets compiled to your vanilla JavaScript. So that's good. I mean, they have added a code, right? That hey, you don't have to write that complex code. Here's what we have given: a simple syntax. There's no more quotation. Very specific, human readable. That's you write it, and we take all the hard work and convert it back into the ARM templates. That's
correct.
Promising. So here's an Alan asking: Is Tushar, what are the plans for functions within Bicep?
So, okay. So basically, I'm not sure on the basically what is the pipeline from Microsoft side in terms of integrating the function, like bringing functions with Biceps, right, at this point of time. But if I can say, definitely, since it is very tightly integrated with the platform, right, we might see it very soon. Because anything and everything that is coming in at this point of time on Azure side, it is totally coming in. Even we see a lot of traction towards Bicep in terms of like converting the existing codes, even Microsoft repositories, right? Every repository you go, there is a pull request over there, and there is some guy who has given, okay, this is getting translated into Bicep, or maybe I have translated already into Bicep. Okay, so definitely we might see that in very soon.
Okay, so Tushar, here's a tricky question, right? All this on past 25 minutes, you have been taking a favor of Bicep, right? And you're telling, hey, I don't like JSON. You don't like. Many people don't like JSON, right? Especially from people who write code like C# and maybe Python, correct, right? JSON is something that we people don't connect a lot. Now, here's what Biceps is still new, although it has been in the market for a very long time, right? It is still new to the field of ARM templates and Azure deployment. Where do you see as a day-to-day user that, hey, this is something that Biceps still needs to improve, more specifically with the Azure ecosystem?
Okay, so basically from Bicep side, right? So I'm not taking a lot of favor for Bicep. Right? So I see there is a lot of good tools, as I was mentioning, right? We have Terraform available, and Terraform is like quite a popular one at this point of time. And also people love Terraform. And also when it comes to multi-cloud environment, right? When you are talking about Azure, AWS, and other platform, then you do not want to go ahead with Bicep looking at what all good functionality it has to give. But what I have seen with specifically with Terraform, right, within my experience, when it comes to Azure or when it comes to any of the cloud, right, since bringing it up from a third party, right, integration with all the services, that is not that good by what I'll say, because any service that is newly launched in Azure, right, let's take an example of something coming in SQL Server as a preview, you'll not find that in Terraform. Those all things we are getting in with Bicep. If an enterprise which is specifically focused towards Azure, if your day-to-day job totally lies towards Azure only, right, definitely you should be going ahead with Bicep. And I see a lot of areas where Bicep is also improving. Like as I mentioned, one area, right, there was 6 months back, if you have to deploy Azure Bicep template, you have to make up this Azure Bicep compile command, and it converts into ARM template. And then again, you are doing the same stuff that you used to do for deploying your Azure ARM template. It's just you're not writing your ARM template, but you are deploying it the same way. And I was totally against that. I was not using Bicep at that point of time, to be very honest. I was like, okay, I'm going to use my old ARM templates. I'm going to plug in there and I'm going to deploy it. But then they improved it, and now at this point of time, you can deploy it with a single line of command. So everything happens on the back end. You do not need to worry about it. There is also a lot of areas where we see, because all the things integrating, even from IntelliSense perspective, right? Integrating all the SKUs that you have on Azure side and integrating all the new functionalities that is day in, day out coming in, right? It is going to be one of the pain areas where the team is focusing, I believe, at this point of time, because I have been following their GitHub very closely. And also there are certain areas in terms of integration as well that they are focusing at this point of time. So those all will get resolved very soon.
No, that definitely makes sense, that relying on a third party is always, you'd always kind of lag, because if it's coming internally from Microsoft, right, you'll always have an edge on the others. So yeah,
Correct.
Bicep will always have an edge on the others. So I think that's an advantage Bicep will always have. Absolutely amazing, Sachin, Tushar. Really happy to connect with you, and in a different way, right? I don't know after how long we're connecting, at least 4 or 5 years maybe. The last years of MSPs, the one who are graduating didn't put a lot in there, or maybe we were asked to go out. Let's put it that way.
No. I graduated and then everything, like we got disconnected from that.
Yeah, we got disconnected. So any final thing, Tushar, you want to plug in before we move to the next session?
Yeah, definitely. So it was like a great platform to speak here. It was, and you guys have been very good facilitators over here, right? From the very beginning, you guys have given all the great details over here, and I see a lot of good speaker lineup. So everyone who is attending, please do attend the coming days as well. You will get to learn everything, and you'll also see me as well asking a lot of questions there and attending all the sessions.
Yeah, thank you so much, Tushar. Thank you so much for accepting the invitation. Really appreciate it. Loved your session, by the way. I'm gonna ping you back anytime soon for many more sessions. So yeah, have a nice evening ahead, and goodbye. Take care.
You too. Bye-bye.
All right, with that absolutely amazing session by Tushar. I was just recalling when I met him, but we didn't meet in 2018. We met him in 2017. So it's been like 4 years now. Okay, so with that session by Tushar on Azure ARM now got Bicep, we now move to our next session. Our next session is by Annie, but she cannot make it. How sad. Annie couldn't make it, but it's not like we have canceled the session. She's going to join us on another day. I believe the next week she's going to join us. So for today, what we're going to do is we're going to how much time we have? It's 8:50 US time and 8:50. Yeah. So we have about 30 minutes of this session. And for that, we're going to take a quick commercial break. And after that, when we come, we will watch one more session of Azure SQL by Javier. Ta-da.
Hello, everybody. Good morning, good evening, good afternoon, and welcome to Cloud Summit 2021. It's a pleasure for me to be here today presenting in this great conference. Thank you so much to the organizing team and the sponsors to make this kind of event possible for all the community. Today, we will have a quick introduction to Azure SQL. We will see all the different flavors that we can have in Azure of the database engine that we all use and love. A little bit about myself. My name is Javier Villegas. I am from Buenos Aires, Argentina. I work as an IT director in DBA and BI services at MSC. I've been working with SQL Server for over 20 years. I am Microsoft MVP in the data platform category since 2016. I am Microsoft certified trainer, and I'm also member of the board of advisor of the Azure Data Tech community. I also define myself as a technical speaker in where I go to all the events that I'm invited to talk about SQL and Azure SQL. On the left side of the screen, you have all my contact information, email address, LinkedIn, Twitter, and my blog. Feel free to reach me if you have any questions in regard to this presentation, or if you just only want to connect. So let's start. This is how I would like to picture Azure SQL, right? This is this new umbrella that Microsoft put just to group all the SQL offering in Azure. We will see three main components plus one which was added recently. The first one is Azure Virtual Machines. This is basically what Microsoft called infrastructure as a service. It's a virtual machine pre-configured in where we can run SQL Server. The same SQL Server version that we've been using forever, right? This is quite interesting because from the Azure portal, you can go there and select from the gallery any combination between operating system, SQL Server version, and edition. You know that since SQL Server 2017, we can run SQL Server in Linux, right? So we can also choose whether we use Windows or Linux, whether we use SQL Server 2014, 17, 16, 19, Standard Edition, Enterprise Edition, the one we need. What it is really interesting is that if we choose one of these predefined images from the galleries, we have certain best practices regarding to SQL Server already pre-configured. Like, for example, how you distribute the data file, the log files, the location of the 10DB, several things. It's important to mention that this offering infrastructure as a service is something that is quite similar to what we've been doing today on premise, right? We have to handle the infrastructure behind SQL Server. So we also have to administer the operating system and the VM. With that, if you need to apply a patch to your Windows Server, to your Linux, this is something that you have to take care of. If you have to apply a patch to SQL Server, right, it's also something that you have to take care of. If you need to set up, for example, authentication, Windows authentication, or Azure logins, right? You also have to set up your own virtual machine, run Active Directory, etc., etc., etc. If you need to set up high availability and disaster recovery, you have to create the window cluster with an additional virtual machine, configure the clustering, configure the availability group, do the whole thing, etc. So this is something that we've been doing today. Also, if we need to take care of doing the backups, right? this is something that we need to take care ourselves. Nowadays, Microsoft is also trying to help us with all these tasks that we need to do in order to maintain the environment, like the backups and high availability, maybe doing some of this point easier from the Azure portal, right? But again, this is something that we have to control. We have to take ownership, right? And the beauty of this option is that since it is the same SQL Server version that we have and we've been working on, right? A migration from our on-premise environment to an Azure virtual machine is extremely easy, right? Because it is the same SQL Server version. Then we have the other option, which is actually two options which are under the category of platform as a service. What is platform as a service? Well, Microsoft provides us with a SQL Server endpoint in where we just connect to that endpoint and we don't have to worry about the infrastructure behind the scene. We don't need to worry about the host, if it is Windows, if there is a missing patch, nothing, right? This is platform as a service. So we connect to the SQL Server. And all those things that I mentioned before, like, for example, backups, patching, high availability, disaster recovery, those tasks are covered by the service itself, right? We don't have to worry about doing those kind of things because it's part of the service. It's really, really a good option, right? And let's describe the two offerings within the platform as a service offering. First one is managed instance. Managed instance is something that we can define as almost 100% compatible with SQL Server, right? But again, as a service, right? When I said almost 100% compatible, we can say that all the features that we've been using from SQL Server, like, for example, replication, CDC, service broker, all the T-SQL that we know, of course, triggers, store procedures, SQL Server mail, everything that we know is there. There are only a couple of things that are not fully implemented, but beside that is, again, a great solution for hosting our SQL Server application, our SQL Server databases, right? Without any big re-engineering or of the application itself, right? So this is managed instance, focused to be a replacement of our SQL Server virtual machine or our SQL servers on-prem, right? With the benefit that we said before regarding to platform as a service. This is a relatively new service in Azure. Then we have another service which is actually not that new, is Azure SQL Database. And in fact, it was one of the first services that were available in Azure when it was presented many years ago, right? Again, under the concept of platform as a service, without us taking care of patching, high availability, etc., right? We have this offering, which is a little bit different than managed instance. And what is the main difference, and why we have two different flavors here? Well, Azure SQL Database, one of the main characteristics is that everything had to live within the same user database. What do I mean with that? If you have an application which requires the database, and the database has a procedure which is joining tables from different user databases, you cannot use Azure SQL database as it is, right? Because again, everything, all the objects from my application have to live within the same user database. So if this procedure, which is joining tables from my user database, but it's also joining tables that are in a different user database, well, we cannot do it as it is, right? For that, we have the possibility of having managed instance, which is more, I mean, much more similar than SQL Server, right? So is this a limitation? Definitely not. I mean, just having everything on a user database is not a limitation, it's an important characteristic and something that we have to consider here is that Azure SQL Database is more targeted to modern application, right? So let's say if we want to come up with some sort of rule to see which one we use, how, when, etc., I will say that the easiest way to do the first step migration is, let's say we have this application running on premise for many years and we want to go to Azure, right? The easiest way to do it is, okay, we come up with a virtual machine with the same SQL Server version that we are using, or maybe the latest one, and we also migrate the SQL Server version. This is going to be the simplest one, right? But right after having the application up and running in this virtual machine, we should start testing and checking the possibility of using this existing application using managed instance, right? The migration from SQL Server to managed instance is as easy as taking a backup and restore it to the managed instance. It's really, really easy. But if, let's say, we have a request to start working on a new project, right? A new development that will require a database engine as a backend, definitely we need to take a look to Azure SQL database, right? Again, if we start writing from scratch, most probably Azure SQL database is the right choice. If we need to migrate something that exists, well, most probably, I mean, virtual machine is the first choice, and then the final home for our application will be managed instance. So here we have some points of each of the offerings, right? Something to review maybe later. But what I would like to focus on is on this difference between infrastructure as a service and platform as a service, and which are the benefit of all this offering in Azure. First of all, we have this concept of business continuity, right? We do have multiple options that allow us to have a highly available environment in Azure, right? In any of the options that we mentioned before. In terms of backups and backups retention, and also backup, let's say, storage, or where do we store those backups that we do, right? Azure gives us the possibility of handling the backups automatically, having a retention of several years, actually, and with the addition of having a copy of those backups in multiple Azure regions. Right? Those are things that are really, really important, because if we're trying to certify any of the ISO certification, well, this is one of the important points that is required, right? How we do the backup, how we retain the backup, and how do we store those backups. Then something really, really important from Azure, and something that, you know, with Azure SQL we can take a lot of advantage is the scalability, right? We can really easily scale up or scale down any of the three offerings that I mentioned before: virtual machine, managed instance, or Azure SQL database. If we have today this environment running on premise and we need to, let's say, add more memory or improve the disk performance, or maybe add more processor, well, it's a little bit, it's a complex process in where you know, you have to buy the hardware and you know, physically put it within the server. That could take some time, right? Weeks or months. Well, within Azure, if you need to assign more resources, CPU, memory, disk, to any of the Azure SQL offerings, right, it's a matter of few clicks, right? So easily you can scale up or you can scale down. Azure SQL Database, initially there was a model called DTU, based on DTU, Database Transaction Unit. This is still there, but now Microsoft is also recommending the vCore model. And again, we have the general purpose tiers, business critical tier, and there is an additional tier called hyperscale, which is a great fit for big database deployment, right? If we are talking about hundreds of terabytes, definitely hyperscale is the tier that we need to consider. User experience that we can have with SQL Server, but with the other offerings. If we go to the portal, right? We go to the main portal. We have Azure Data Studio to work and connect to any of this offering. Again, absolutely no problem. All right, so this was a brief introduction to Azure SQL, right? Another good benefit is that with Azure SQL, you can integrate it with many other Azure services like Data Factory, Cognitive Services, Azure Databricks. All the Azure services are really well connected with Azure SQL. So if your project not only required relational database, but also required any other component related to NoSQL, big data, machine learning, you can easily integrate it in this you know, scenario. Okay, very good. I have a final slide here, just to, you know, if you want to learn more about Azure SQL, I leave you this QR code to go directly to the Microsoft documentation. Everything is well detailed, and you know, the documentation is really great. And with that, we finish this presentation. Again, I have my contact here, so LinkedIn, Twitter, email. Don't doubt to contact me if you have any question regarding to the presentation. And with that, thank you so much. Have a great conference, and we stay in touch. Bye.
All right, everyone, welcome back. So that was a recorded session by Javier. Unfortunately, he couldn't make it, so he just sent us the recorded session. And this was a replacement of a session by Annie, who was going to talk about the Kubernetes. Having said that, the following session would be a live session by Maik Gaag. I hope I say his name correct. He is a Microsoft MVP and a CTO. And in today's session, he's going to talk about on how you can add additional security to your Azure PaaS. Security is something that many people during the registration of Cloud Summit really wanted to learn. So I'm 100% sure that all of the people watching now and the people who will watch the archived session will get to learn a lot from this session. Having said that, without any further ado, let's invite Gaag to Cloud Summit 2021. Hi, Mike. Welcome to Cloud Summit 2021.
Hi, Simon. Thank
you.
you.
How are you doing today?
Yeah, I'm doing fine. A little bit busy, but
yeah,
I'm okay. And you?
Yeah, I'm doing great. And the 5 days at the Cloud Summit has been absolutely amazing. I know you are a CTO, so definitely you are a busy person. I won't take much of your time, Mike. We all are looking forward for your session. That's on security. People really want to go ahead and learn security in this summit. As we had in the registrations, we saw it. So I've added your stream to the live stream. Everybody can see it. And the next 20, 25 minutes or 40, 35 minutes is all yours.
Okay, great. So let's get started. So hi, everyone. Welcome to my session on how to add additional security to Azure PaaS. Like many of you may know, and many of you already been using as well, Microsoft has a great Azure PaaS platform of Azure App Services, Azure SQL databases, and a lot more like logic apps and functions as well. And everyone is trying to use it or operating it in different kind of ways. But one of the, I would not say downsides, but one of the sides of Azure PaaS is that it's open by default to the whole wide world, meaning that you have complete connectivity from every place in the world to your services. And not many people think about how to secure that and how to use that in a default and a different kind of way. But let me further introduce myself. I already saw some nice pictures Simon dug up from the internet, some very old as well. Like he mentioned already, I'm a CTO at 350. I'm also a Microsoft certified trainer, so I do a lot of training sessions as well on Microsoft related topics, mainly cloud topics and DevOps topics as well. I'm a Microsoft MVP, and I'm the founder of the Dutch Cloud Meetup, which is a meetup group based in the Netherlands where we do a lot of sessions. And next week we hope to do our first in-person sessions in 2 years. So I hope everything will go okay for that as well. But to get back to the topic, Microsoft has some default recommendations around security for your PaaS platform. And I also included some of myself as well, is that if we look at this list, your PaaS platform should require authentication, meaning that you should be able to connect to your services as well and maybe add authentication mechanisms from Azure Active Directory or maybe a third-party provider as well. Next to that, you should protect your backends with authenticated access, meaning that, for example, if you build up an API and you connect that to Azure SQL, for example, you need to make sure that the connection between those services is secured as well by using, for example, managed identities. You can also use a user-defined service principal, but Microsoft really has a great platform for using managed identity as well, really making sure that you do not know the security information about those service principals, but are able to connect as well. But also be sure that you secure those backends as well by using Azure Authentication, for example. Of course, use HTTPS only and not only HTTP. secure your application data. So really make sure that your application data is secured. And for example, if you look at keys and everything else, make sure that all these informations are saved in a key vault. Really making sure that the connection data you are using to get, for example, to your SQL database, if you use SQL authentication, make sure that that is saved to a SQL database. If you, for example, also save information about service principals, make sure that it's also saved in that key vault. Use IP restrictions, really making sure that not everyone is able to connect to your application. That's basically the most easiest way to restrict access to your application, but you may never know where people are coming from. And basically the last one is using network isolation. In my opinion, that's one of the most easiest one to really make sure that your application is secured. But in many situations, that's also the most expensive one. Microsoft mainly uses that as a recommendation of securing your application, making sure that you have network connectivity for your application, but it's also one of the most expensive ones in the Azure platform. But that's why basically during this presentation, I will take you through some examples of security mechanisms you can use within your application that also leverage different kind of ways and not making default values like the network isolation is possible. One of the most easiest one, and that's already prepared in the platform, but that you should only activate, is the Azure Defender. Azure Defender is not as less a real security mechanism, but helps you with information around the security of your application. So Azure Defender can be activated on different scenarios. So it can be activated for servers, activated for storage accounts, but also app services and SQL databases, and help you detect several threats that you have on your instances. So it will not really mitigate the problems you have. No, it will only alert you about something that's going on your machine and something that will be going on your server as well. So it will really detect anything else. So it really is not securing your application. So let's look at the options that we then have for securing the application. So as you can see here in the picture, I've just drawn up a firewall between the user and the app service. It's basically using something like access restrictions. You have that on app services, but you, for example, also have that on Azure SQL databases. It's the real, easiest one, like I mentioned before, for restricting access to your applications. And it allows you to specify specific rules on your app service, or for example, on your SQL PaaS database, to deny or allow access to those applications. Really making sure that people are coming from a specific location in the network. If you know the specific IP addresses of the user, you can secure that as well. But for example, you can also use service tags, meaning that, for example, if you have a specific API that's also lives in Azure, you can also add additional service tags for specific IP addresses of Azure services. So let me show you that as well. So I will just stop sharing this screen and let me check if that. Let me just, this is the most easy way. Don't be scared because I will appear on the screen myself. So so if I'm not mistaken, everyone should be able to see my Azure portal at this moment.
Yep. Okay,
great. This is my Azure portal. This is basically my own personal environment where I have several subscriptions and several things configured as well. I mainly use template specs to deploy all my resources against this environment. So I specify specific ARM templates that deploy my services. So I use those services as well for all my demonstrations. And if we just go to the app service that I have here. So I have here a basic application service deployed with an application service plan. And of course, also application insights, because I mainly use that for monitoring of my applications. So if we open up this app service, I have a networking part of this app service, and I can see here that I have And this is basically a new interface regarding network connectivity for your app services, where you can see that I have a part of inbound traffic, my web app itself, and my outbound traffic. Basically meaning that, for example, access restrictions will take place regarding inbound traffic because it says something about the inbound traffic coming in. I can click on access restrictions and I can see here that I have specific deny rules placed on this environment. So basically the source from 10.0.0.1/32 will not be able to enter this application, and basically also have a deny all rule, so meaning that nobody will be able to access this application as well. One thing that's mainly forgotten when working with app services is that if I supply access restrictions on my web application, I also have something called the advanced configuration side of app services called Kudo or SCM. You can see here it as well as a tab, and it also has a tab within the access restrictions. Basically, SCM is mainly used for doing file-based configurations, or it's also used for publishing the files to your application itself. But if you secure the website itself, you should also think about how to secure the SCM part, because that's a default part that's always available on an app service. And it should be configured in a kind of way itself as well. As this is a main part of your application, you do need to require authentication to get in there, but you also need to look at how it is secured as well. And also thinking about if you deny, for example, everything but except one location, and you do the same for SCM, you also should think about how you deploy your resources to that application. Because denying every IP, meaning that you also need to make some hole in the access restrictions to be able to deploy the application itself. Maybe do a temporary import of an IP address, but you should really think about that as well. Let me just go back to this one. What I also want to show you is basically the authentication part. And that's basically the part I just discussed within the 6 points as well. You are really able to very easily add authentication to your app services by just selecting Microsoft. You can create your own app registration, give it a name, if it is for a specific tenant or maybe a multi-tenant environment as well, and if you want to require authentication. Saving this and adding the additional permissions. So maybe your SPN that you are using needs some additional permissions to read the information from Azure Active Directory or something else. You can configure that as well. As basically by selecting Add, everything will be configured and you will have an application that requires authentication. So let's jump back to the presentation and look at other ways of doing restrictions, access restrictions, and retrieving of data. So basically the next one is a VNet integration. A VNet integration makes sure that your application itself is able to access information from within a network, from within a subnet. It's basically an integration into resources within the network, meaning that it's not a real security mechanism, because the only thing that will be done is you have your web application, you still have the inbound traffic coming from the internet, but the application itself is able to connect to services that's in your specified network. So it only says something about the outbound connectivity of your application, meaning that it's able to connect, for example, to an on-premises Azure SQL database. And not as less saying about how someone is coming into your application. Many in the world see the network integration part as something like, okay, I now have network integration, so I can connect to my application from my network, but also into my network as well. But that's basically not the case. So the inbound traffic is still coming from the internet, and the outbound connectivity is still going to your network. So that's basically the difference between those two. So if we look at the Same internal environment I just shown, and again go to the networking part. So I already shown you the inbound and the outbound, and you can this makes it very easy for you to see what connectivity is talking about what kind of connection. So I'm not sure if someone still knows the classic interface, but for example, if we go to the classic interface, and this is the classic UI for the network configuration feature, and that's also where the difference comes in making that UI more appropriate for the connection, is that you still have the VNet integration that has a description securely access resources available in or through your Azure VNet. Really making you think, okay, I can use this VNet integration, and then my app service itself is integrated into my VNet. And it really pops in the mind as well, okay, maybe then I can also connect from my VNet to my application. And like I just told you, that was not the case. And basically this new interface really makes you see that as well, is that the VNet integration only works for outbound traffic. Configuring this VNet integration is just basically connecting your application, your app service in this example, to a specific subnet of your virtual network, making sure that you can do inbound traffic within the virtual network, maybe also into pairing virtual networks if you want. And you're also able to secure, of course, your resources in your virtual network via an NSG. But nothing is done regarding security through your application. So you really also need to think about the inbound traffic and the inbound security, because nothing is handled there as well. So you really need to combine two functionalities. So like you saw in the previous window, it's somewhat too far. You have to combine the inbound traffic and the outbound traffic configuration for your networking capabilities to make sure that you have a secure application from access restrictions, but you also have outbound traffic to your virtual network. So if we jump to another section, and you can see here a really important note, inbound traffic comes from the internet. So if we jump to another option that there is basically Azure Front Door, and you can see it here with two app services. So Azure Front Door is mainly used in scenarios where you also want to have some underlying traffic and load balancing enabled for your applications, being, for example, one application in West Europe, and for example, another application in France, or even in the US if you want. Azure Front Door mainly makes sure that you can secure that application in some way, but you can also do load balancing between those two, meaning that if I connect to one of these applications, it gets me to the most quickest one, and it also does this by living on the edge. So global Azure Front Door is a global Azure resource, meaning that it lives on edge points of Microsoft, really not specifically to the data center locations. And from that point, it travels over the internal Microsoft network, meaning that if I, for example, I'm now in Rotterdam, if I would have an edge location in Rotterdam, I would directly traffic to that edge location, and from that edge location to a specific data center of Microsoft through the Microsoft network connections, meaning that I will have a very fast connection to my backend services. By default, Azure Front Door has an integration with app services, so it's very easy to configure and very easy to specify how it needs to work. Like I mentioned, it has load balancing capabilities with failover, of course. So if one region will go down, the other one will take all the traffic. You could do SSL offloading. It also has content caching, so you can really make sure that the content is specified and still comes from the edge location, where it's more fast and everything else for your application. And you have a central application dashboard where you can view everything regarding the application. Besides that, there is a lot of protection already built into Azure Front Door, together with a web application firewall. So you can really make sure that every component of your application is secured, and also make sure that some specific traffic can't come in. Also, all regarding, for example, DDoS protection. You can blacklist IP addresses and whitelist IP addresses. You can do geo-filtering based on the location a user is coming from, filter it out into the request. You can have flexible actions to allow, block, or lock anything else. You have custom HTTP access rules. You have rate limiting for PCs, so you can really make sure that one client IP address cannot connect to your application too many times in, for example, 1 minute. And you have Azure managed rule sets. So there are specific rule sets for that could do cross-site scripting checking and pre-configured SQL injection. If we look at front door from an Azure standpoint, and let me just navigate to another resource group, and that's my secured web app. So what you can see here is that I have somewhat the same configuration, and I now only have 2 app servers. So I have a 001 that's based in West Europe. I have a 002 that's based in Front Central, and I have a global resource called Front Door. This is basically the Azure Front Door application, and I also have a Front Door web application firewall policy. And of course, I have the app service plans, and again, the application insights for doing my monitoring. So if you move to Front Door, you can see that we have some default overview regarding the request counts, everything is being used, and we have the Front Door Designer, giving you one dashboard for your complete application where you specify how Front Door should work. Front Door mainly works with a front end, a backend pool, and specific routing rules specifying how traffic should be routed to different applications. So if we look at the front end domains, you see that we have one specific front end domain. And if we would open up this front end domain, you should be able to see a demo application, and we can see that we end up to my demo web application that's located in West Europe. So if I would close down one of the backend pools, it will mainly direct me to Front Central. We do not use Session Infinity in this example, and we also use a web application firewall. So we specify also here as well is that everything going to this front end will use that web application firewall to check the traffic. I will show you the configuration later on. So you could have, for example, multiple web application firewalls configured, and based on the front end domain, you could pick one of those as well. If we look at the backend pool, you can see that we have 2 backend services configured. So we have a backend pool azurewebsites.net 001, and we have a 002.azurewebsites.net. So those are basically the 2 app services I configured. And for those endpoints, we also have some health probes configured. So we have a health probe that just connects to the Azure app service itself, checking if the app service is still alive. So if I would stop one of the app services, it knows that the status is not disabled, and it will just kick over to the other one with an interval of 120 seconds. Meaning that if I would close down one of my applications at this moment, it would take roughly 2 minutes before the other one pops up. So you could really increase this as well if you want. And we also have the load balancing part here as well. And to complete everything, you also have the routing rules configuration, where you have specific routing rules depending on how you want to traffic to your backends. And in this example, it's just a simple routing. So if I go to a specific page, I will be redirected to that specific page as well. One of the important things of using Azure Front Door is that it not completely secures your application as well. So to give you an idea, I have a Front Door application. So this is basically my front end that redirects me to one of my backends. And this is basically one of my backends. And if I would open up one of my backends, let me just go here. That's basically my West Europe backend. And I would open up this URL. I would now get a 403. You would imagine that Front Door is blocking all traffic to this backend. But that's basically not the case. What's been done here is that on this backend, I also configured access restrictions, meaning I've specified that connectivity coming from my Azure front door is allowed and everything else is denied. So by default, that deny rule is not there. So if we would look at the access restrictions, you can see here that I have one specific rule with a priority 100 called front door, and basically the source is front door backend, meaning that the backend of front door is able to connect to my backend, in this example 001.azurewebsites.net, but everything else is not. So this rule isn't here by default. So for example, when I have front door configured, everything would look like this. So everything is allowed, meaning that I still have the front door application, so I'm still able to connect to the application via front door, but I would also be able to connect via the default URL. Basically, not going through the web application firewall and basically going around it as well. So if you configure front door or any other service as well on the platform, really make sure that you look at all connectivity options and look at if the connectivity options are also closed down as well. Because the main thing you would think is that it would be there as well. So let me just add this rule again. And you can see here that it's very simple as well. I just give it a description, give it a name as well. Let me just call it front door again. And in this part, I can just choose a service tag. And that will give me all kind of service tags coming from Azure. I can search here for front door. And I need to use the backend because everything is coming from the backend part. Basically, this configures specific IP addresses of Microsoft, of the Azure front door. That's are of course dynamic, that can change. So you do not require to add all kind of IP addresses to this part. So to continue, I'll just show you the web application firewall as well. This basically contains a lot of rules by default for securing your application. You can see here of already a complete list of everything that's being checked in this web application firewall by default. So I did not do anything to configure it except creating the web application firewall, of course. But you also have the ability to create your own custom rules. So as you can see here, I created a simple rule for a rate limit to block traffic if it's coming from the Netherlands. If I do more than 10 requests in 1 minute. So this really makes sure that you have the abilities in place to secure your application in all kind of ways you require. And you can even add additional options here as well to block traffic or to allow traffic on specific configurations. So now we had Azure Front Door, where Azure Front Door is more used, I think, in the practical sense of the word, is in production scenarios where you host websites or you host public stuff that you also want to secure in a right way. There are also options to do it more or less for example, internal websites within your organization or internal applications that you want to host internally, but not move directly to a situation where you configure an isolated environment. So what you can see here is this, in this picture, is that we have, for example, an Azure App Service. This Azure App Service it has VNet integration, so this one is able to connect to my virtual network. Just in the second example, I have a laptop that has a VPN connection to that VNet, and I have two PaaS services. In this example, an Azure App Service and a SQL PaaS instance that uses an Azure Private Link. With Azure Private Link, you are able to expose an app service into a virtual network, meaning that you will be able to connect from the VNet to your app service via the Microsoft network capabilities. So you're not going over the internet. No, you can privately access it from the Azure platform. Meaning that, for example, you can also supply NSG rules, because in the end, you will just get a network interface that's placed in a VNet, in a subnet, and you can build your NSGs on top of that. So this basically protects you to any data leakage, still has the private access, but there are also some important things about it. Let me just go through the technical details later on, just in a small demonstration. But it's really important to know, for example, that for app service plans, you require the premium v2, premium v3, or the functions premium. Outgoing flows will not use the private endpoint, meaning that it's basically in the same scenario of the VNet integration, but then the other way around. Private links will make sure that you can privately access your application, but outbound traffic will not go over the private endpoint, meaning outbound traffic goes over the internet. So here again, maybe you will have a situation where you have two options. One configured with the private endpoint, and one configured with the VNet integration to be able to have that internal traffic. So configuring a private endpoint on your app service disables all public access. So there will be no public access to your application, meaning that you can only access it via the internal network. When you're not in the internal network, you will not be able to access it, and you will also not be able to access it by placing additional rules. When configuring the private endpoint, the web application will not use the access restrictions anymore, meaning that you have to supply access restrictions via NSGs. So the private endpoint really delivers you a network interface for your network. So you really need to make sure that the inbound traffic to your applications is filtered by the subnet NSGs or the specific NSGs you configure on the virtual network. So the access restrictions are not evaluated anymore. When using private endpoints for your Azure SQL databases, make sure to restrict public network access. By default, public network access is still activated. So also adding a private endpoint to your SQL database doesn't make it secure by default. You still need to do some configuration to make sure that it's only connectable via the virtual network. Let me jump into the demonstration as well. So if I go back to my dashboard, I have a secured database. I also have the secured web app. No, this is the wrong one. Let me just open up. Yeah, which one is the good one? Yeah, this is the one. In this example, I have an internal application, and this internal app service has, like the picture I've shown you, internal VNet connectivity. So it's able to connect to services into my VNet. This application can be accessed publicly. So if I would open it up, it will just open a web interface and shows me some data. This data is coming from an API. And that API is hosted in my virtual network via a private endpoint connection. So if we just go back to the resource group, I also have the app service private. And basically that is connected with a private endpoint. So if we would look at the network configuration of this service, networking, I see that I have a private endpoint configured and set to on with a private connection name with the state approved and a specific private endpoint. In this resource group, you can also see that I have the private endpoint itself, and I also have the network interface. Here comes some routing things. So you can also see that I have a private DNS zone supplied. This private DNS zone is connected to my virtual network to make sure that I am able to connect to that private endpoint as well. So if I open this up, I can see that I have a DNS zone for private link.azurewebsites.net. And basically that's an alias for the .azurewebsites.net. You can see here that it's pointing to an internal private IP address. of 11.0.1.3.4. And basically the same for the SCM side. So it's also only available privately. So this app service itself is only accessible privately via the private link at azurewebsites.net. This is configured as an alias, so I can still use the main domain of azureappservice.inweb.private.azurewebsites.net. If I open this up in a browser, for this one it would not work because I have that endpoint configured, so public access isn't allowed here. But for example, if I would just switch on my VPN, as I have a VPN configured as well. Yeah, that's my Azure VNet. Let me just connect. Just a simple point-to-site VPN connection, and it's now connected. You can see here that it does not work. The page cannot be found, and that's of course it's already connected via the VPN. If I just type in Swagger, I see that it's an API, and I can retrieve a weather forecast as well. So basically, this API is configured and totally secured and only accessible within my virtual network. Really making sure that people coming from the internet are not allowed to make direct connections, but can only connect via this interface. So this interface also still works because I'm in the virtual network, but I also have internet connectivity as well, of course. So you saw this applied to an app service, but in this example, we can also use it on other services in the Azure platform as well. So you can see here that I have a small example of a connectivity to a SQL Server database, where I also have a private endpoint, and also, again, have a specific network interface for that private endpoint. What you can see here as well, I also have the private DNS zone, but I now have a different private DNS zone. I have a private DNS zone for privatelink.database.windows.net. This DNS zone is also connected to my virtual network. And this also has a configuration for one specific database with its IP address internally. Being that is, you really need to make sure that when creating private endpoints and private links as well, that you create a DNS zone, and that DNS zone is specific for databases. So meaning that if I want to deploy an additional private endpoint for a different database, that entry also needs to be saved in the same private DNS zone. So I cannot create multiple private DNS zone with the same name. So really you really need to populate this list of your private endpoints as well. Last point that was important, that was also shown on the slide, is that on the database, you have, of course, the firewall configurations, and you really need to make sure that you set this toggle to yes. Setting this toggle to yes really makes sure that you can only connect from your own virtual network to the database and not from the public internet anymore. So you can even run a SQL database that's scaled at $4 a month, connect that via private endpoint, and make sure that it's secured as well for a real cheap database as well that's privately connected. So lessons learned, basically doing these kind of things for customers in other practical situations as well. Securing the application is much harder than just saying it. Saying it is very easy, but you also need to make sure that you do it the right way, and you also keep checking that you have access to the default services. And also be sure that not everything is blocked by default. So always go out from worst case scenario where things are still accessible and check if those are accessible as well. Next to that, you also have to apply security during the design of your solution. Don't think, okay, I will just create an app service and later on I will think about security. No, start thinking about security right away and really make sure that everything is connected and everything is secured in the right way as well. Some resources. You can find some really good resources on your Microsoft Doc site about the security baselines for your app services, private link for SQL, but also for app service, of course, and Azure Front Door. Next to that, there is also a link here in the slides that points you to my GitHub page where everything is saved for my Azure platform. being that you can find the Bicep files, the ARM templates, and everything else that I use to specify my demos. So if you want to get started working with Private Link or Azure Front Door, I have some really good examples there on my GitHub repository that you can use to deploy the complete demonstration I just show you very quickly as well. Looking at the time, it's at the end of my session as well. So if you want to get in contact with me, you can come in contact with me via LinkedIn, via Twitter, or via my website. And if you have additional questions, you can always email me at mikevandegaag@350.eu. Thank you, guys.
That was an absolutely amazing session, Mike. You know, I mean, everyone who would go ahead and watch your session would definitely get to learn a lot from what you have shared. We do have a couple of questions coming in. I know you're really busy, so maybe let's take two of them. The first one is from Vijay. He's asking how to test the app service once denied configuration for external connection that are enabled. Consider I don't have to provide individual dev QA IP address access in workload. I don't know. I couldn't get it while I was reading it, to be honest. You have to be a little more specific, right? This is, I think, it's like more scenario-based question. Never mind. We'll try other time. Vijay, just try to be a little more descriptive, right?
If you just, for the people that are asking the question, if you want to have more information, just contact me via LinkedIn or Twitter. It's very easy. And then we can have maybe more of a discussion regarding that question, because in all security questions, they are all really specific and case specific as well. And regarding testing, you just need to check the HTTP connectivity to an app service.
So what I'm going to do now is I'm going to update Mike's name, and I'm going to add his Twitter handle. There you see, I have updated his name over here, so you can always go ahead and ask him. Let's take one. Let's try to answer this one if you can do it. Sonia says, can Azure Front Door replace Azure Application Gateway, or you would recommend deploying an application gateway behind Front Door?
I think I would recommend the application. I would not recommend the application gateway behind your Front Door, because you also have the web application firewall options for Azure Front Door. But there could be maybe situations where you will do that as well. So it really is case dependency.
All right, Mike, that was absolutely great session. Any final thing before we finish the day 5 part 1?
No, success with the rest of the event, of course.
Thank you so much, Mike. Thanks for accepting the invitation. Really appreciate it. We have many friends in the Netherlands. I hosted Henk the other day, and there are many people speaking from your region. Thank you so much. We'd love to have you back next year offline. You never know. So thank you so much. Take care of yourself, and see you soon. Ta-ra. Bye.
Thank you. Bye-bye.
All right, with that final session by Mike. Oh, my neighbors are a little rowdy. Never mind. It happens. I cannot control. So that's the end of day 5 part 1. But here's what, please join here now, right? After here, we're going to go live on Microsoft Developers YouTube channel, and we're going to go live on Learn TV from here. So please go ahead and click on this link, right? And join this session, join from here. We're going to take about 30 or 25 minutes break. And having said that, as you all know, whenever we end a part, we always declare the winners of the contest. So the winner for this part 1, I've always said, whenever you ask a question to speakers, please use #CloudSummit tag. And okay, this is Iqbal saying, thank you again, Mike van der Gaag, for your detailed session on this particular subject matter related to aspects of cloud security. Oh, he's not here, but I can say thank you on behalf of him. Many thanks coming in. So thank you. Looks like people really loved his session. So all right, let's go ahead and let's see who wins. Lucky draw. 3, 2, 1. I need some drum rolls. I need to add some music over here. Some drum rolls coming in. Let's see who wins. Oh my goodness, who wins it? No, C-Sharp cannot win it. Oh, Andrew McCullum. Oh my goodness. Andrew has been very consistent from past 5 days. Congratulations, Andrew. Take a screenshot of this. Drop us an email at simon@azuresummit.live, and we'll make sure that we ship you the goodies sometimes next month, because this event goes almost to the end of the month. Having said that, thank you so much, everyone. Please join here. I'm going to drop it again, the link. Please join here, or just visit azuresummit.live, and we're going to just update all the videos over there. So yeah, that's it. I will take a break of about 25 and 30 minutes, and we'll see you on channel 9. Yeah, also on channel 9, but more on Learn TV. Yeah, see you by that time. Enjoy the commercials from our sponsors. That's also very, very important.
Life in operations. It's a mix of planned and unplanned work. Operators frequently find themselves getting interrupted with an endless stream of tickets, often for doing the same things over and over again, and those tickets are often escalations to yet another team. Resolving these tickets leads ops teams to searching documentation and runbooks, looking for steps to complete routine procedures. Hopefully, the docs are up to date and the operator has access, and they don't make a mistake. And of course, that the business can afford to wait. Wouldn't it be great if there was a better way? What the operators really need is their runbooks to be automated. Here's where Rundeck can help. Rundeck by PagerDuty is a leading solution for runbook automation. Customers use Rundeck to delegate automation to the right people in the organization. Now users get self-service access to operations that previously only subject matter experts could perform. Rundeck automates IT workflows and processes, replacing the previously manual procedures found in documentation. Rundeck doesn't replace existing automation. It makes existing automation, scripts, and commands more secure, auditable, and safe to run. Rundeck is a central hub for automation, connecting key tools and infrastructure in operations workflows. Rundeck helps teams resolve incidents quicker, avoid interruptions, and get more done, all while ensuring things are locked down and remain compliant. First responders are empowered to resolve incidents themselves instead of escalating, minimizing disruptions and reducing outage time. Operators become more productive. Developers stay focused. IT users can solve problems for themselves with the click of a button. Rundeck customers regularly see 60% shorter incidents, escalations cut in half, and 15 to 20% increase in productivity. Sign up for a demo today.
ScriptRunner, the #1 for PowerShell management. We get it. You were hoping that PowerShell would save your day, but you figured out that it is not user-friendly for non-experienced colleagues. Managing the increased demand on IT is a growing challenge, and running scripts manually is still very time-consuming and complex. Welcome to ScriptRunner, the #1 for PowerShell management. ScriptRunner runs on PowerShell scripts. It combines everything you need to efficiently manage and automate your complex IT infrastructure. With ScriptRunner, you'll be able to make it easy for your team to perform administrative tasks without any knowledge of PowerShell, have a transparent overview on all PowerShell activities, and most importantly, free up your IT resources for more relevant tasks such as innovation and development. Download your free trial now and unlock the power of PowerShell.